Here we have time, sir. Please collaborate with us. We will implement the implementation part. I will take care of, sir, at our institute. We have
Okay,
big
no.
expertise in that, so that if you want us to do whatever as per your wish, we will do that.
Yeah, definitely, definitely. Definitely. Okay, ma'am. I will see you by, I will log in again by 11:30 probably.
Okay, sir. Thank you, sir. Thank you, sir.
So
Sir, could you please share your biodata, sir?
I have mailed you just at night.
Okay, sir. Last night actually,
Basically, I have not updated my biodata for last 1 year, but
Okay.
in February I just fixed it up, and you can brief it as per your requirement. You
Okay.
can directly include that publications in the areas of, you can find out in the area of image processing, signal processing, hardware and instrumentations. So you can include those also.
Okay, sir. Okay, no problem. Okay, sir. Thank you, sir. Thank you, Mr.
Okay.
Good morning, Sridhar sir. Hello?
Good morning, madam.
How are you, sir?
Good, ma'am. Thank you. How are you, ma'am?
Fine, sir.
Good morning, everyone.
Good morning, Sri Lakshmi ma'am. Hello, Sridhar sir. Hello, Sridhar sir. Hello.
Yes, ma'am.
Sir, could you please send your data, sir?
I had already shared, ma'am. You must have received my email.
Okay, okay, sir. Thank you, sir. Sir, join us.
morning, madam. Am I audible?
Yes, sir. Good morning.
Okay, thank you.
మాదే పంపించాలి నువ్వు జాయిన్ అవ్వలేదు అబ్బాయి Sir, only 1 minute time is there, so we'll start at సరే సార్ అప్పుడే కనవండి అప్పుడు Good morning, everyone. I welcome you all to the second day of SPS Summer School program on IoT in Biomedical and Healthcare Applications. We hope you find yesterday's sessions insightful. Today we have 4 talks by eminent speakers and a panel discussion on empowerment of women, challenges and opportunities. Alongside a poster presentation, the panel discussion starts at 6:30 p.m. today, and we hope you all will be present there. Now, without any further delay, let us start with the first session of the day. I invite Darshan to introduce our first speaker, Dr. Rashmi Ranjan Raut, sir. To you all.
Thank you for the opportunity.
Please, can you introduce, sir?
Thank you for the opportunity, ma'am. Good morning, everyone. Our first talk of the day is on eminent applications and communications protocol in IoT by Dr. Rashmi Ranjan Raut. Dr. Raut is an experienced teacher cum researcher who has received his PhD from IIT Kharagpur. He is a project guide in the areas of wireless ad hoc, sensor networks, and Internet of Things. He is currently working as a professor at the Department of Computer Science Engineering at NIT Warangal. His research interests are mobile computing, wireless ad hoc and sensor networks, online social networks, cyber physical systems, Internet of Things, network security, and cloud computing. He is a senior member of IEEE and a life member of ISTE and a member of ACM. We are really pleased to have you here, sir. Please proceed.
Ma'am, you are on mute.
Hello?
Yes, ma'am.
I request all the members, please switch on your video once. We'll take one snap, afterwards I will continue the session.
Madam, also one thing, I am not getting that sharing option.
I will
Yeah, please allow me.
present it. Jigal sir, are you there? Sadia?
Ma'am, I'll join in the afternoon session.
Only we will take one snap. Sir, I have given privileges, sir. Rashmi sir.
Yeah, I got it. Yeah, thank you, madam.
Welcome, sir. Thank you, sir, for accepting our invitation, even though you have busy schedule. So whenever we are requesting, sir, for accepting, thank you very much, sir, for your support all the time.
Yeah, thank you, madam. Welcome. Can I start, madam?
Yes, sir, you can start, sir.
So good morning to all of you. So my talk will be mostly giving an overview of IoT and IoT key technologies, emerging applications, communication protocol. We'll be discussing on sensor-based solutions and IoT nodes, emerging applications including healthcare, key technologies associated around IoT, communication protocols and standards used primarily in IoT, IoT cloud integration framework, and how these IoT and cloud, although they are two different technologies, how they are integrated, and I'll also introduce some of the candidate operating systems for IoT nodes and the importance of machine-to-machine communication in IoT. If you see the Internet of Things, it is a network of physical objects. Then the physical objects may be devices, vehicles, buildings, and other items embedded with electronics, software, sensors. We must have network connectivity among these IoT nodes. So when we say that Internet of Things, then this is a network, or you can say through Internet, different type of physical objects, they can communicate. Right. Physical objects may be devices, vehicles, buildings, and other items embedded with electronics. Those, if I say our building or a building or a school, a building in a school or a building in an office will be a part of Internet of Things, then we need your electronics devices to be embedded or to be along with must have electronics or some devices should be integrated or deployed on those devices so that the device will be capable of sensing through sensors. The device should be capable of taking computing something. So that will happen with electronics and software. Right. And if a device, a real world device or the thing in the Internet, if it is sensing some data through embedded or through sensors available or integrated with the device, it is not enough only a sensor which is deployed in a building or any other physical object. Then what to do with that data? So that data must be processed by the node, and the data must be shared through a network. So that means in the Internet of Things, what we want are the devices must generate data on their own using sensors. For that, the physical objects or buildings or vehicles must be embedded with electronics, software, sensors, as well as they must have network connectivity by which the data can be shared among themselves so that a task can be accomplished. So all these enables these objects or these devices, vehicles, buildings, and other items embedded with electronic software, sensors, and network connectivity that enables these objects to collect and exchange data. So that's what we want from IoT devices. As well as we also expect the devices not only sense the data and communicate among each other. The devices must do some. There must be some intelligence in these devices to take some action, to take some decisions. When what type of events are occurring in the environment in which these devices are working or they are deployed for. Then what you want to do and what type of problems you can solve using Internet of Things, that will be discussing, and what type of standards, protocols, healthcare applications, along with other smart city applications, what we are going to, or what type of problem we are going to solve using Internet of Things, that we will be discussing. So a thing can be defined as an embedded device based on a microcontroller that can transmit and receive information. Right? So that means the physical objects integrated with electronics, software, devices, software, operating system, embedded in an IoT device is a software, right? and different type of sensors integrated in an IoT device, such as temperature sensor, humidity sensor, your healthcare sensors like pulse rate monitoring, right, as well as other type of or heartbeat monitoring or other type of monitoring related to healthcare, your related to other healthcare applications. Those things must be the data which are generated from those sensors must be shared with other devices or can be pushed towards a central entity, a central server or a cloud where data can be further processed and some decision can be taken. So that is most of the applications are towards that now. So just to introduce this, your thing, actually thing can be defined as an embedded device based on a microcontroller that can transmit and receive information, as well as the thing also can take some local decisions based on the amount of computation available locally at node level, right? So that means decisions can be taken locally, decision also can be taken globally, right? So those kind of things we will be discussing, how we can take global decision, how the node can take local decision based on the data available at node level. Now, these things are physical objects. They are homogeneous or heterogeneous. Now, interconnection of heterogeneous objects. Okay, so now I say these things, these physical objects embedded with electronics, software, sensors, and having the capability of network connectivity, this entire structure of IoT or this network is heterogeneous. When I say heterogeneous, then I say these objects are heterogeneous means the devices will have the resources available in those devices will be heterogeneous. What are the resources available in an IoT device? The amount of computation available, computation power, the amount, the type of sensors embedded into embedded into a physical object. That is, those are different. Some are having humidity, temperature sensor. Some others are having healthcare sensors. Some others are having agricultural sensors. Right? Even if that means the type of sensor which we are going to deploy, it depends on the type of application where we want to deploy this. Along with that specific application also, in a specific application also, the devices also may be heterogeneous. So that we'll be discussing more on that. But when I say heterogeneous, what I say the devices will have unequal, or that means there is a heterogeneity in terms of resource availability, including computation, memory, operating system, your sensors available in those nodes. At node level, the devices are heterogeneous. You see your mobile phone and somebody else's mobile phone. You will find there is a difference in computation among these mobile phones. Similarly, whenever you want to have a large scale network, with a large scale network, different devices will have different resources. I hope you understood that. So that is at the node level, the objects are heterogeneous. Then what about the network level? We say that node is generating data. Then after that, what it will do? It will communicate with other nodes, or it will communicate through, or it will push the data, or it will transmit the data towards the central node. It will transmit the data towards the central node, and that time also it will have the network will be heterogeneous. So what I mean by network is heterogeneous? That means if you see the internet is a large scale network. Now some of the hops, some of the links are the bandwidth available at different links may be different at a different hops if you consider end-to-end communication between source and destination. Right. That means the link bandwidth will be heterogeneous. When I say link bandwidth, you can say your both sides of the link, uplink as well as downlink. Both the links may, as well as among the links there will be your heterogeneous bandwidth. Suppose you take a road network. You see the road network in traditional road network. In a road network, you will find some roads are national highways, some roads are local ways, right? Some are 2 lane, some are 4 lane, are your roads. Then that means the amount of traffic in a road network that can pass through or maximum amount of data or traffic what can pass through a road network will be unequal based on your type of the road network. Similarly, in networks, in the internet, will have unequal bandwidth depending on the network standard, your bandwidth, network standard, and available your bandwidth at different links. The bandwidth will be unequal. Okay, so therefore the network is your heterogeneous. The nodes are heterogeneous. In that situation, whenever you try to provide a solution, then you want a end-to-end communication between end devices such as your sensors and your a centralized server such as cloud, right? I'll show you those type of architecture, right? So then, in that case, if unequal bandwidths are there at different links, then whenever you are sending and when we are uploading and downloading some data from an end IoT device to a centralized cloud, right? And centralized cloud to your end device, from end to your end device of your then there will be lot of issues, network issues you have to solve. Okay, I hope it is clear. So network side, the IoT is heterogeneous. Node level IoT is heterogeneous. Your application level also, when we are generating data and the structure of the data, IoT data is also heterogeneous. Okay, so that means IoT data is heterogeneous. Means you will have a different type of schema. Being with such a heterogeneous environment where nodes are heterogeneous, data also heterogeneous and dynamic, as well as your network is also heterogeneous. So providing solutions is always a challenge, and there will be a lot of research issue in this heterogeneous environment. So what we are expecting and from the cloud, and why we want to sense? We want, our requirement is to sense the world, right? So what sense the world means, various types of applications, whatever there in the world, we want to sense it. Now, the requirement, because there is a requirement of sensing the world and making those data and processing the data for smart decisions. So that is the requirement of the day. I hope most of you might be already acquainted with a few things about sensing. And for sensing, what we want sensors. So sensors can enrich human interaction with the surrounding, right, across the world. Sensors create a more interactive world. Sensing an object, communicate with other objects, analysis of sensor data at the cloud level as well as the local level is always some kind of challenge due to heterogeneity in the controlling an object remotely through the internet. That is another requirement. That means not only we are sensing the data, or not only the IoT devices are sensing the data, the IoT devices are also can be controlled through central or central point, all the devices, IoT devices also can be controlled. Okay, so that means we are saying both way communication. That means from end IoT devices to the cloud. Cloud is a central unit. Okay, and from the cloud again, or from the central unit again, we can control the IoT devices which are deployed on the ground to solve some kind of real world problem. Okay, so both way we are basically trying our requirement in IoT based projects. Our requirement may be both sides. Some of the requirements, some application may be one side, right? Communication, and some other side, some other application we may need both side communication. Then whenever you are dealing with the sensors, then you will find that these IoT devices integrated with sensors will have limited energy, limited bandwidth, network will have limited bandwidth, and devices will have limited energy. All the layers must be, when we are going for a network, we are building when we are building a network, and you might have remember, whenever you create a network, you study about layering, network layering, where in computer networks you have different layering concepts, such as physical layer, data link layer, network layer, transport layer, and your application layer. Right? In TCP/IP model, right? There you define the protocols for those layers, right? Now those protocols are used for communication at various levels. At physical layer, some protocols are designed for physical layer, some protocols are designed for data link layer, some protocols are designed for the network layer, like IP, Internet Protocol is a network layer protocol, right? IPv4, IPv6, a network layer protocol. Transport layer protocol, TCP, UDP, these are transport layer protocol. Application layer protocol, as you know, HTTP, HTTPS. There are different type of application protocols. Okay. Now, when I say that I am designing a network, and especially IoT-based network, then we have to think for or to minimize the energy consumption. The protocols which you want to design for IoT devices, which are operated, most of the IoT devices are operated by battery. So then energy is an issue. Okay, and as well as network bandwidth is also an issue in IoT devices or in IoT networks. Right, all layers must be energy aware. So whenever I am designing a protocol for different layers, then I say the protocols must be energy aware or energy efficient protocols you have to design. So need for energy efficient and reliable network routing. Routing is your network layer functionality, right? If I take this one physical, data link, this is data link, this is physical, and this is your network, and this is your transport, and this is your application, right? So if you take in that way, then routing is your middle layer is your routing. This is your network layer. Okay, so energy efficient and reliable solutions when you are designing various routing methods to route so that data from your end devices can be communicated with a centralized device like cloud. Okay, so you have to also maximize the network lifetime, maximize the lifetime of the IoT devices. The devices also should run longer time. If you are designing an autonomous network using sensors like wireless sensor network kind of thing, then you have to improve the lifetime of the network, or you have to maximize the lifetime of the network. For resource management is required. Transmission power and bandwidth, you have to address these issues. You have to address the issue of onboard limited energy available. With limited energy, you have to manage the resources such that your lifetime can be improved for the device, for the network. Processing capacity is limited, therefore you have to take a decision whether some data can be processed locally and some can be processed globally, right? So that means some uploading of some tasks should be done by the IoT devices. The uploading can be done, or the task uploading can be done by the devices, and the task can be executed centrally, right? So that there will be less load on the IoT devices, on end IoT devices, you can say. Okay. So similarly, storage is also limited in those devices. Therefore, careful resource management is very much required, keeping in mind limited resources at the node level, limited bandwidth at the network level. That's what I want. So based on functionality of the sensor node. Now sensors are integral part of IoT. And how these IoT devices are different than traditional computers? In earlier you said desktop computer. When you are using desktop computers, we think about running desktop applications to generate data. Right? Now, when you say IoT devices, immediately people will ask you, okay, what type of sensors you are using, what type of data your IoT device is generating from the environment, from the application domain, from where you deploy the IoT device. So then you have to deal with such type of sensor. And sensors may be of many types, as I told you that suppose I say some sensors may be generating data like your temperature, humidity. Some are air modeling sensors like carbon dioxide, carbon monoxide. Right? Even if some are camera sensors taking the images, right, or generating images, and those things will be processed somewhere centrally, right? So therefore, devices can generate data. That means some of the nodes may do only sensing. Some nodes can relay the sensed data or received from other devices. That means some other nodes in the network may have the role of relaying the data sensed by other nodes towards the central unit. Some nodes may be doing both sensing as well as relaying other data. And whenever you are deploying the sensor, suppose you are deploying sensors or inside your campus, you want to design, you want to provide IoT-based solution for your campus, right? Then you have to identify the type of sensors you want, right? And you have to identify the deployment strategy, right? And you have to identify how many number of sensors required. If some of the nodes are inactive, can you have a backup sensor for your campus so that the sensing coverage as well as transmission range, or by considering transmission range and sensing range of the nodes, you have to design an autonomous network for your campus. Okay, so that you can generate different type of data. Suppose you want to operate your some kind of data regarding what is the pollution level inside your campus, or what type of poisonous gases are coming or are being generated, or what is the carbon monoxide content coming, and this type of gases may have some impact on the human body. So for that you want to go for, you want to deploy such type of sensors inside your campus. Right? So you may be working on that. In that case, then you have to decide the number of nodes required for your campus, given the area of your campus. Then whether when some of the nodes are inactive, can you have some backup devices to take its place so that sensing coverage can be maintained. When I say sensing coverage, then I say what? Coverage. That means any event occurs in your campus, right? So must be detected. So that means no point in your campus will not be in coverage of your some nodes. That means your campus should be fully covered. There should not be any such point which will not be covered by at least one of the systems. Right. So therefore, always you have to see a full coverage where your campus is fully covered, or the sensing range of the nodes must be covering the your on the based on the sensing range of the node, you will be planning your deployment in your campus so that you will get a full coverage of your campus. Like suppose I say you want to deploy your object detectors, okay, around your boundary wall of your campus. Okay, so such type of things mostly when you say you are deploying, so you want to deploy those sensors in such a way that even whenever an event occurs, so that should be sensed by at least one of the sensors. So then I say I'm getting sensing coverage, or I'm getting full coverage. There are so many other things also I am not discussing at present. And as you know, after sensing, the data must be transmitted to other sensors, or it may be transmitted to another gateway through which this data can be pulled towards a central unit like cloud. So then you have to also keep in mind while deploying the sensors a transmission range of the node. That means at the nodes which you are deploying, the range of that node, that means within the transmission range of that node, there must be some other sensors which may relay this the sense data which are coming from this node. Right. So you need that within the transmission range of a node, there must be some other sensor nodes to relay its data, or that within the transmission range of that, the gateway itself should be there where the data can be pushed to the cloud. So therefore, by keeping in mind transmission range and sensing coverage, you have to go for a practical deployment of sensors in a given geographical area. So whenever you are providing a sensor-based solution, then to ensure energy efficiency, low cost, reliability during operation of the network is important. Types of sensor networks based on data collection initiative, or types of various types of based on types of events, we can categorize them. There are periodic updates of sensor data, periodic updates like I say we are monitoring your temperature, humidity, we are generating or sensing data and sending it to a central unit or through a central gateway. Right? That is clock-driven periodic updates. Right? So the period can be decided. For example, is you monitor temperature and humidity of the atmosphere or at your campus where you want to deploy. Right? These are periodic updates. Event-driven, when an event occurs, like object detectors. When an event occurs, when suppose there is a fire. So if there is a fire, then that should be the nearby sensor should change or to they should sense the data, and the periodic updates or the sampling period of generating data must be changed autonomously to capture the event like fire. Okay. So demand driven, any kind of request comes from the user side through the central node towards the deployed region. So such type of application also you have to deal with, or hybrid of among some of them. Different stages of data collection, you have to activate those sensors or sensor nodes. Then you have to configure the network or through a control message dissemination. Some kind of your network must be established. Okay, so that the nodes must know each other. The nodes must discover their neighborhood, so that you can build a multi-hop network. Okay, so if you're within your IoT device and a gateway, if single hop is there, then it is easily you can do it. But when you say that no, my gateway is a little far away from my sensor nodes, then you will have multi-hop communication between your gateway, through which you can push the data towards the cloud. So when you will have end sensor devices and your gateway to have multi-hops, then the neighborhood discovery and all those things also may play some kind of important role. And finally, the data delivery. So there are different type of architectural issues, and your performance of multi-home wireless networks depends on various types of architectural issues and implications depending on the type of application, where you want to deploy, what type of application, what type of sensor you want to use, where you want to process the data locally or globally. So those things comes under that. And network dynamics, some of the IoT devices may be mobile, some of the sensor devices may be stationary. That depends on the application where you want to deploy. Suppose I say you say that you have some robots kind of thing, then you will have some kind of, you have mobility in the robot, right? And when you say that no stationary sensors deployed, you have any kind of healthcare services or agriculture or somewhere for some stationary nodes, right? So then nodes may be mobile as well as stationary. Then the events may be static, like temperature, as I told you, and events may be dynamic, like target detection, or as I told you that if there is a fire, we have to find out the spread of the fire, or we have to determine the spread of the fire at all. So node deployment may be deterministic and self-organized manner. Nodes can be deployed, right? So deterministic is placed manually, like in your campus, you can deploy the nodes wherever you like. You can access those rooms or the field, whatever. But when you say you want to deploy underwater Internet of Things, underwater objects you want to monitor, and that you want to control, you want to provide a network or through Internet, you want to access the data, you want to control the network which is there underwater, right? So in such a case, you can't access some part of the network. Your physically or a human being accessing it may be difficult. Therefore, you can go for other types of deployments, scattered randomly, deploy them, right? Manually placed under the sea may not be feasible, so you may have to randomly place them. Okay, or you may throw them, or various methods you have to adapt to do that. Then the nodes must self-organize themselves to build a network. So this the node deployment comes when you want to deploy an autonomous sensor-based solution you want to provide. So based on application, you have to decide whether it is a deterministic approach or it is a scattered random approach of deployment, when the nodes will self-organize themselves by control messages. They will find out and the network will be set up. Now, when you this is about whatever we have discussed, mostly about sensor-based solutions, sensor coverage, and how the data will be generated, what type of sensors we want, what type of sensor-based solutions we want based on applications, and how the data can be sent through the gateway to a central unit. Now, coming to see the current network, you will have various changes along with time. Actually, the network concept changed. You know, traditional network with nodes and links, that is your LAN, and LAN internet. So in your lab, you will have desktops, you have a local area network in your campus maybe, and where your desktop are connected to switches and all, you have LAN connection, and you also access to the internet. But here, we are not discussing anything about sensor-based solutions, and we are thinking about applications or desktop applications will generate data. That data will be shared to other computers, or can be shared to a centralized server, or can be shared to a centralized cloud. But here we are not discussing that when we are saying LAN and all, we are not giving emphasis on the sensors. And as well as these are physical networks. Okay, but in IoT we are mostly dealing with sensors, how the device can generate data on its own with minimal human intervention, right? How the devices can communicate among each other autonomously, intelligently. That is our aim actually. Okay. Whenever this is a physical, this is a traditional network. If we go back some years, you will have this type of thing. If you say we have a LAN and we have internet like that. Right? Then after that, you will have another type of network that is called peer-to-peer network or overlay network. Here, some of the that means the network is you can build a logical network or virtual networks where you can share different type of materials among the logical nodes, or any node can share data with any other node, or it can share files and any other data with other nodes. Mostly people say those are like Bitcoin and BitTorrent. These are file sharing systems. Okay, so this is the next generation, next to this traditional physical network, to this overlay network, or you can say logical networks. On top of a physical network, you can run multiple overlay networks based on the type of application you want, and based on the type of file sharing or other type of sharing, different types of file sharing applications you want to build, then you can build this peer-to-peer network. Examples are Cloud, BitTorrent. If you search, you will get these terminologies very used. But currently, what you see, the networks are further virtualized. So here only we are talking about sharing some data among the nodes, and so that searching can be easier, and that means those are primarily file sharing system. But here we are saying currently you will see the online social network. That means here in online social network we are sharing data, mostly personalized data, and this is a virtual type network. IoT networks, you also see the current generation IoT networks where we are saying not only this personalized network, but the network must also generate data through the sensors embedded or inbuilt in sensor nodes. So that is your IoT network. And the next technology what we are, before some time I have taken the word cloud multiple times. You might have already heard it. Okay. Now cloud technology networking is basically cloud provides different type of services, right? Like your infrastructure as a service, your software as a service, your platform as a service, your data as a service. So various kind of your services cloud provides. Okay. Now IoT networks are also recently gained its popularity of providing various types of solutions, and it needs the help of these cloud services. That's some of the architectures I'll be discussing. Although these IoT networks and cloud networking are two different technologies, but IoT is getting services from the cloud recently. Different types of applications people are building for that. So as the day progresses, you know, various kind of applications are your sensors where things are embedded. So more things are being connected to address a growing range of business needs. In fact, billions of things are connected to the internet. It is maybe 7 billion, 7 times our human population, or beyond that also. There will be devices in IoT. Wearable healthcare services, performance monitors, connected vehicles, smart grid, smart homes, and various IoT applications are coming up. This IoT Internet of Things will change the way the life was running, and it will solve various real-time problems for us, and it will automate various processes. The processes may not be only for computer science or ECE, engineering discipline, or electrical, it may be mechanical, civil engineering, and other government applications. So this completely the Internet of Things is solving problems, or it provides various solutions to for the various engineering disciplines or real world problems. The Internet of Things is the intelligent connectivity of physical devices, driving massive gains in efficiency, business growth, and quality of life. Now I am here introducing the term intelligent. That means not only these devices will communicate among each other to accomplish a task, but they should intelligently communicate among each other. They should intelligently take decisions locally, as well as they can offload some of the tasks whenever required, whenever the resources are not available at local nodes. Those tasks must be offloaded or sent to the cloud or a centralized server where these global decisions can be done. Right. So we need intelligent solutions from this Internet of Things. Whenever you want to design one end-to-end IoT system, then you have to keep in mind what the researchers will do. Researchers have designed and developed various hardware and software platforms to support IoT applications. IoT mostly keeping in mind the application, the research and development should happen. That means the type of IoT device which will be suitable for healthcare may not be suitable for agriculture. That may not be suitable for other government applications. Right. So therefore, the type of we have to analyze the application. Based on the type of application, we have to customize the IoT solution. Starting from the customizing the design of the node. Customizing the node means now you understood we have to decide the sensor, the type of your board. If I take the various types of IoT hardware platforms, we may have Arduino, Node MCU, Raspberry, various types of hardware platforms we have to choose along with the type of sensor for the specific application like healthcare, right? So to provide or to generate data, and that data must be through application it should be processed, and the data must be pushed towards the your centralized cloud. Okay, but while designing those things, you have to see that how much computation available locally at the node level, how much computation can be done. With that, managing with that much computation, if you get some additional computation to be done, then the tasks should be uploaded, or the tasks should be sent to the cloud. So therefore, mostly it is more research and development oriented towards the application. There are IoT, heterogeneous IoT, your networks are there, where different types of your IoT networks. When you see that, then various network architectures used in IoT, wireless sensor network, Wi-Fi, cellular wireless mesh network, vehicular network. That means a node belongs to different the sensor network, Wi-Fi, cellular network, wireless mesh network, vehicular network. They can communicate or they can send their data from the application domain. They can send the data to a centralized cloud, and they can also talk to each other whenever required. So therefore, this IoT is a network of other networks, right? And those networks are heterogeneous networks. Okay, when I say heterogeneous networks, the bandwidth is heterogeneous, right? So the network bandwidth is heterogeneous, that you will have multiple challenges when you are communicating data. A heterogeneous network needs employ RFID, sensor, and other smart terminals to solution. When you are providing a solution, you have to see that your 24/7 you will be generating data and you will be communicating with a centralized unit to a central gateway and all. So if you see this architecture, this is a sensing layer. So through a sensing layer, using the sensing layer, we try to build sensor nodes. And for the sensor node, already I told what are the different components. after building an IoT node using appropriate sensors and appropriate computational storage resources at node level, using node MCU, using Arduino board, using Raspberry, various kind of devices. After doing that, then we find some nodes, whatever we would design, they can't communicate directly with a centralized gateway. Then there will be multi-hop communication between these nodes. Then you have to build a network. If the end node can directly communicate through the gateway to the cloud, then it is fine. But if it is not, its communication range is limited. Your IoT node, what you are using, its communication range is limited. Then other nodes may relay its data so that the data will reach the central gateway, and finally the data will be uploaded to the cloud. Okay, so this is my cloud layer. So then what I say, the local decision should be taken locally, either at the node level or some part of the network. Local decision also can be taken based on the type of network we design, whether we will go for a cluster network. If you design a cluster, then you will have some kind of central gateway or cluster head where you can take some local decision based on local data available in that region. But you want a global decision, the data should be sent through the central gateway to the cloud, and here your global decision will be taken based on the data available from the deployed region. Right? The cloud will get the entire data from this deployed region. Then cloud takes global decision. Data analysis, IoT data analysis, multi-data at the cloud level. So other applications, if you can see, some other applications like mobile communication network, various users through various applications they generate data. Suppose some users they generate data, they take snaps or their devices generate some images, they will share that data, they will upload that data to the cloud. Okay, so then from mobile communication network for using various types of crowdsourcing applications, data can be sent to the cloud for that further data analysis. Similarly, vehicular network, devices from vehicular network can send data to the cloud through a satellite network or any other type of network. Okay, so this is what more or less we are dealing with, this type of architecture recently, where you have sensing layer, you have a networking layer, and through some gateway you are sending the data to the cloud. And because the sensor nodes will have limited resources, they can't execute high-end computation tasks. Therefore, those tasks must be sent to the cloud for execution. So, similar using Amazon Cloud, people are using ThinkSpeak. If you go through this for IoT platform, okay, for this to provide various types of IoT solutions. So IoT devices can be connected to the cloud server by internet or satellite. I have discussed about this. Okay, the last point, the monitor at the central server intelligently processes and analyzes a large amount of data to achieve the smart control of objects. That's what I told you. You not only whenever you do analysis at the cloud level, whether after analysis, if there is a communication, if there is a need for communication from the cloud to the sensing layer to send some kind of signals to automate some kind of devices to control some kind of smart objects, that also can be done. So that means sensing data from the sensing layer to the cloud and from the cloud to the sensing layer, both way required whenever based on the type of application for which we design IoT solution or we provide IoT solution. So there are various applications in industry, agricultural, transport, smart home, where the data is being sent to the cloud for processing. So data is being sent through the internet to the cloud for processing. So when you see the architecture, you are getting a centralized architecture which is recently used, that is IoT and cloud architecture. As I told you, you can generate data and you can send like various IoT and cloud platforms. Another architecture is peer-to-peer architecture, where these applications themselves can share data, not through the cloud. So if you can build such a peer-to-peer network, that will be your peer-to-peer architecture. So that means if some kind of data required, suppose you say take healthcare. Suppose from the healthcare application we want some data, transportation, right? From transportation we want some data, right? For healthcare. So if these two can communicate among each other directly rather than through the cloud server, so any application can generate, they can communicate among each other to generate, to share data without intervention of a centralized cloud, then that will be, you can say that is a peer-to-peer architecture. Okay. So one IoT application to another IoT application to access services if there is a communication, right? So when there is a need, whether it can be done, and this will be a completely decentralized architecture. However, if you see this one is some type of centralized architecture, IoT and cloud, because we are generating data and sending to the cloud for global decision making. These are some of the wireless application, IEEE 802.11, that is your primarily that is your Wi-Fi standard. This is the Zigbee standard, primarily used for sensor networks, now also used for IoT devices. IEEE 802.15.4, similarly cellular network, 3G, 4G, and beyond. You will be using these networks to connect the IoT devices, to connect to have a that means the IoT devices can communicate using this network through a centralized gateway to send the data to a centralized server for further processing. So similarly, IEEE 802.3 and name of some IoT hardware platforms, as I told, Arduino, Node MCU, Raspberry. There are various kind of devices available, and you have to customize these devices, identifying the sensor what you want to provide a solution for your problem or your problem domain for which you want to provide an IoT solution. Mostly communication in your healthcare systems. Communication related to Internet of Things or healthcare can be classified into two domains. Short-range communication. This is I'm going towards the specific healthcare application. Classified in two main categories: short-range communication, long-range communication. Right. As I told you already, sensing coverage I told you, transmission range I told you. Therefore, what I am saying here, the communication related to Internet of Things for healthcare can be classified into two main categories: short-range and long range. The former is used to communicate between devices within the wireless body area network, while the other with the human by taking human body, and we want to generate data based on various for various parameters of human body. Suppose if I this diagram, suppose in human body we have embedded or these are some kind of wearable sensors which monitors pulse, fall detection, your respiratory rate. So for various parameters, healthcare parameters, to generate data from our body, so we need some kind of sensors and IoT devices. These devices which generate data from our human body for various healthcare parameters, they send their data, the sensors, the IoT nodes send their data to a central node. Now, the central node, again, is also in human body, right? So these are some sensors where wearable sensors, patient is wearing, and as well as there is central node. Suppose I say some kind of gateway kind of thing. Suppose a mobile phone, if you can make it in a gateway or any kind of dedicated gateway. Through that, data aggregation this should be done. Right. If there is some deviation somewhere, those things should be sent, or regularly those monitor data also can be sent to a centralized cloud, where we can do some kind of analysis using machine learning, and based on that, your general practitioners, specialists, nurses, they will access the centralized cloud and they will get information about the patient. Okay, so this is what I am discussing. This type of architecture where the healthcare of a human being are the various parameters, healthcare parameters related remotely when the data is available at the cloud. Then the question arises, why cloud? Why we are taking this generating data? Then why we want cloud? One thing is the data. Already I told you these devices will have limited processing power, limited storage, or you can say limited memory. They can't process high-end tasks. Those things centrally all data around the clock. Even if you say present data for 1 month data you want to process, so that should be done at a central point such as the cloud. And why we are saying it is a cloud? When we are saying it is a cloud, we assume the access is provided to the other stakeholders who are going to monitor that data or can access the particular data about a particular thing. Therefore, when we are putting in a public cloud, so we are making the access easier, or you can say the data is reachable to the your doctors and nurses who will access it. Okay, even if the patient is moving, even if the patient is at multiple destinations, those can be data regarding that patient can be monitored and processed. So this type of architecture currently we are dealing with this, right? Okay, so then that is what mostly a body area network what we are dealing with. So we are dealing with short range communication, long range communication. The former is used to communicate between the devices within the body area network, while the later provides connection between the central node, as I showed you, that gateway node of the wireless body area network and the base station, as per the diagram that I showed you. Many short range communication standards exist, especially for healthcare. Commonly used ones are Bluetooth Low Energy, BLE, and ZigBee. Low Power Wide Area Network (LPWAN) are a subset of long range communication standards with high suitability for IoT applications. The range of LPWAN is generally several kilometers, even in an urban environment. So LPWAN also have advantage over cellular networks such as 3G in that they are designed to support short bursts of data infrequently. So this standard of what it deals with short bursts of data infrequently. This is suitable for a large number of healthcare applications, including monitoring general health and receiving hourly updates. Monitoring critical health, receiving emergency calls, rehabilitation, where updates may only be necessary once a day. So that means regularly we are not, we don't want patient data every 2 minutes or 5 minutes, right? We may need data in short bursts. So therefore, this standard provides that. So this allows for low power device design, which in turn ensures that the designed healthcare devices will operate for longer before human interaction is required to recharge the change battery. So that is important in healthcare applications because those they operate mostly the energy is limited and it is provided through some available battery in those devices. So those devices in healthcare must run longer period. So therefore, especially some of the standards, they provide short bursts of data infrequently. The most prominent standards for LPWANs are Sigfox and LoRaWAN. While these standards are well established, they face competition from emerging standards including NB-IoT. So you can you will go through these kind of standards, right? Computational offloading involves using cloud to perform complete data processing beyond the capabilities of low resource wearable device. This point already I told you, right? Now across this your IoT, so what are the technologies we are dealing with? We have to analyze the type of problem, domain, the type of discipline, the type of real world scenario for which we are going to provide an IoT solution. So therefore, understanding and analysis of the application and various parameters are the problem, the given problem to be understood properly to provide an IoT solution. So that, as I already told you, what type of different applications there are. Okay, like whether some kind of event we want to monitor, or it is a continuous monitoring application for which you want to design or develop an IoT solution. So those kind of things we have to analyze to provide an IoT solution. Okay. So if it is a healthcare, then only you have to deal with the healthcare parameters, and for the healthcare you have to understand the mobility of the your ambulance, the mobility of the healthcare mobility and availability of the healthcare worker. Suppose I say healthcare worker. Some data can be accessed by a specific healthcare worker or a doctor when the doctor is available in the hospital, not the doctor when it is available at his, in his office or at his home. That means the availability of data, you are going to provide data availability, or you are going to a stakeholder in a specific application, for example, a doctor, then the doctor is in hospital, not at home. So that means you see that it is not simply accessing the data which is available in the cloud. It depends on the location of the node also, and location of the stakeholder, and the present location of the stakeholder. So that's what I gave you this example. That means based on various attributes you have to give access or data access. So those understanding will come when you analyze the application properly to provide a solution. Okay, I hope you understood. Similarly, some other group of people are working on chip system on chip design. So who are working on designing different types of system on chips. So keeping in mind the type of application, it is healthcare type of product, it is some other kind of a smart city application or agriculture, the type of devices will be manufactured will be different, or the customization will be different at the system on chip level. Mature internet protocols are required because the nodes will have your mobility, nodes will have limited resources in terms of energy. So as already I told you, we need different internet protocols which will address these challenges, these issues which are occurring in IoT domain or in IoT network. Okay, such as mobility, as well as energy consumption or energy efficiency you have to improve or you have to reduce energy consumption. So when you are designing new internet protocols, suppose I say IPv4, IPv6, so I want a mobile version of this to support mobility. I want some more robust protocols, right? I want secure protocols at a different layers also. Like I want a mobile version of TCP or mobile TCP, which will also address these issues of energy efficiency. So such type of mature internet protocols to be designed. Similarly, wireless connectivity, 4G data, or you are dealing with 5G data and technologies. So to support IoT and how the bandwidth can be guaranteed for some applications if required. So such type of things you have to work on. Which type of standard will be required for you to provide a solution for providing an IoT solution given to you. Okay. Cloud network services, as I told, we are providing some kind of services like infrastructure or computation service to the most of the IoT applications. So therefore, understanding on this cloud network services is required, and specifically they should be designed for providing services to IoT applications. And data analytics, if you see day by day, these sensors number of sensors are increasing, and various mobile apps also generating data, and this data are heterogeneous data and dynamic, right? And therefore, there is a great challenge due to this huge volume of data as well. Okay, then we need various types of big data analysis techniques to deal with the Internet of Things. These are some of the key technologies in Internet of Things, and you just can find out whenever you are providing a solution, you are oriented to which direction, or you can confine yourself to one or two technologies, and you can build up your IoT application. Other technologies may be used, but you may not be doing some research on that. You may be using other technologies, but you may be providing. Suppose you are interested in IoT data analysis, so more orientation should be here. Whereas you are using some kind of already existing protocols, your system on chip, or some kind of devices which are available already, network connectivities are available. You are using those services and using cloud services you can provide. But your aim is to more work on this or give emphasis on this. However, you can use other technologies to provide IoT applications. So various emerging applications, we are some other applications also we are getting recently, so in smart city applications and all. When you say an application may be, as I told you, event-centric, continuous monitoring, priority, bandwidth guarantee may be required for application, two-way, single-way communication may be required for some application, local and global decision may be taken for some application. So you have to properly understand the application, the type of event, the type of monitoring you want to do, then only you will find out, then you have to determine the devices, how to generate, how to design a device along with the sensor, along with the required sensors for that particular IoT application, and what type of decision you want to take, a local decision or global decision, that also you have to decide whether the type of tasks you are dealing with, is it, what is the priority of that, is it bandwidth guarantee is required or not. Those things you have to analyze properly, design. So various types of applications you might have heard about, connected rail, passenger comfort, and various type of web services to be provided. Route optimization is also required. Critical sensing is required for high-speed trains. These are you need IoT-based solutions. You need vehicular traffic management in a smart city kind of application. And this one I'll tell you, multimodal city, vehicle parking and all. Okay, as well as guiding ambulance in a smart city, that is also specific to healthcare services. IoT in agriculture, various types of precision farming, autonomous robots we are using in IoT in agriculture. Okay, based on the need of the type of your monitoring you want to do in agriculture. So this is one application on your emergency vehicle routing, like your ambulance, using IoT system development in a smart city, especially for healthcare kind of vehicles. Okay, traffic congestion in urban areas is another concern Another problem that has a direct or indirect impact on public healthcare services. The timely arrival of emergency vehicles or ambulance to the nearest hospital having necessary specialization is very crucial. Now, just imagine that you have an ambulance is moving. Now, ambulance is moving from a village to a city. Suppose you say 100 kilometers. Now, the real-time monitoring of the traffic condition is required for the ambulance, as well as the remote monitoring of the patient through a body area network is required for the patient who is there in the ambulance. That is also required, right? As well as the ambulance, when it starts from a village to a remote, from a remote village to a city, then you have to choose, or the ambulance must find out the hospital where the specific specialization is available, specific doctor is available. So it is not only going to a hospital only by knowing the name of the hospital, by knowing the available specialization, by knowing whether the current COVID is, you see the current situation of the COVID. Now, whether in a specific hospital, whether a specific specialization is available or not. And if next further also you can think of that whether a particular doctor is available or not. You can also think of if beds are available in that hospital or not. So with so much of decision making, really one healthcare vehicle should move. Okay, so mostly if you see here, the timely arrival of emergency vehicle like ambulance to the nearest hospital having necessary specialization is very crucial for the survival of the casualty or the patient. Okay, at least you can find out the necessary specialization is available or not. Further, you want to do something more, you can also do by yourself, right? Then based on that, you have to find out the least congested route. Even if there are temporary road blockages, that also should be addressed. Guiding an emergency vehicle which can avoid temporary road blockages as well and congested routes in smart city. While going towards a hospital where a specific specialization, as I told you, COVID is some kind of specialization, or you say that some kind of heart diseases, one type of specialization. Then where some facilities available or not, keeping in mind the hospital should be determined, the routes should be determined, and even if there are temporary blockages due to temporary road constructions, temporary blockages due to road strikes or something, if it happens, right? All those things also should be available to such emergency vehicles. So in that way, we have also done some work where these sensors are generating data and pushing towards a centralized, you can say, traffic monitoring center. This traffic monitoring center, we can place it in cloud, or we can have keep it in local server, wherever required, whatever required for our application, we can do that, right? So that means the data can be sent to the traffic monitoring center or layer where this data can be processed. Various kind of decisions can be made about route congestion and all. Along with the sensor data, we also can have crowdsourced data from the from various type of stakeholders through mobile app. They can also send it. Crowdsource information, route request and route reply. That means this crowd also can send some route request to know the ambulance drivers can send some route request to know whether such and such route or to reach a particular hospital where a given specialization available, what is the least congested route, by considering the temporary road blockages also. Okay, so then these crowds can send data, as well as the crowd also can provide some data through the mobile app. That means through crowd we can sense data, that will add into the sensor data to take a global decision, as well as the crowd also can, or the ambulance driver also can send a route request and get route reply from the centralized cloud. Okay, so the crowd is doing both. If somebody, if a crowd, somebody, your ambulance driver suddenly find some accident occurred in front, then or any other driver, they can share the data with the central server. That is a temporary blockage. So that type of, then the next time whenever there is a decision on making such kind of route for some other stakeholder, that that route will not be recommended. Okay, so such type of model is there. If you are interested, you can go through this paper. So similar kind, similar type of things is represented here. Sensory data as well as cloud data, where gateway, IoT gateway, pushed towards a traffic monitoring center, and that decision will be congestion aware. Alternate routes will be given to the ambulance to move from a source to destination. Okay. So mostly this shows if there are road blockages, then alternative routes are chosen. You can see the blue color. Whenever there is a road blockage, then the blue color line shows the alternative routes. So these are the dots are road blockages, right? So there are so many other applications. I will just quickly name them. If you are interested, you can go through that. Monitoring water contamination, waste management in smart city, traffic congestion monitoring, decision support system, air pollution monitoring, smart grid metering. Already we have discussed smart healthcare, few things. Means some of the architectures we have discussed, and some application also we have discussed. Smart parking lot management, multimodal transport system. Multimodal transport system means whenever a stakeholder move from a remote village to a central city, from which location to the person will move by taxi, from which location to which location the person will move by metro train, and from which location to which location the person will move by bus or public transport, so that the person has to pay least amount. Okay, so such type of transportation system mostly called as multimodal transport. Okay, so that means you are mostly recommending a person that you use so and so your vehicles from this location to this location. Next you go by metro, then you go by bus. Finally, you have to pay least amount from given a source to destination. Such type of projects are required. E-governance, gas filling, these are common applications where we need IoT solutions. If you see a smart, something more about smart healthcare systems, there are wearable sensors. Wearable sensor nodes are those that measure physical conditions. Already I discussed about that. Pulse, respiratory rate, body temperature, and all. And through a central node, this data will be pushed to the cloud. So through a central node, this data which are generated from the human body will be pushed toward the cloud, where the stakeholder can access that, and then some decision making can be done, or they can send some kind of customized reply or instruction to the patient, so that some action can be taken if there are some issues or health issues found actually. Okay. Okay, this part we have already discussed. Right. Wearable accelerometer sensors for knee monitoring is another application. A healthcare system for knee injuries could be developed by using wearable accelerometer sensors. Measurement could be recorded using several activities such as normal walking, rehabilitation, exercise. So this is primarily for knee monitoring. Similarly, blood pressure, automatic alert generation. There are some of the healthcare services. Blood pressure also can be monitored. Pulse rate measurement, those kind of things with the help of the diagram we have discussed, and commercially several fitness tracking chest straps and wristwatches are available with pulse measurement, HRM, TRI, by Garmin, S7 bipolar. These are the few things. You can go through that. So when you are taking some kind of IoT system, right? So then how you are going to provide a solution? Okay. So now what we have discussed so far, that the IoT devices, including healthcare, they generate data from the deployed region. It's the healthcare. Then from human body, various parameters are sensed and sent to the cloud. Okay. Now, based on that data whatever available in the cloud, data analysis must be done by taking some kind of knowledge from the doctor, so that your various kind of patterns or various kind of decisions regarding healthcare can be found out, so that some kind of instruction can be provided back to the patient. Okay. Suppose somebody has given you some application, then what you have to do? Machine learning is valuable for accurately predicting future events in IoT systems. Which road is going to be congested, which machine going to be down. So that means you take various applications. You have to ask these questions, and then you have to find a solution. You are asking the question, which road is going to be congested. When you are doing analyzing the data, when you are doing some machine learning on that data, or applying machine learning on the data, then you have to ask which road is going to be congested, which machine going to be down. In a mechanical machine, which machine is going to be down. Condition of patient in healthcare, which patient will have severe your health condition or health issues. You are asking that. Then you have to define what is the severity, which parameters, based on what the parameter values severity will come, all those things, right? Which applications are eating more resources in a smartphone, which portion of city will be more polluted. So various types of applications. These questions gives answer, or you can say originate problems, or the necessity to solve problems in various types of applications. So when you are coming to this protocol standard, already I have discussed a few things. Now coming to various communication protocol your protocols in a protocol stack for IoT, right? So this application already I have discussed application, physical, Mac. In Mac we are using 15.4 here, we are using 15.4, already we have discussed this. Now here only this adaptation layer is introduced. So what is the role of an IPv6? This is a network routing protocol and layer, right? And a network layer. Now this adaptation layer is new here. What it does, it brings the gap between an IoT standard, a communication standard like IEEE 802.15.4 and a conventional IP protocol such as IPv6. What it does actually is adaptation layer. That is important in the communication protocol stack. Low energy communication environment using IEEE 802.15.4 spare at most 102 bytes of the transmission of data at higher layers of the stack, a value much less than the maximum transmission. So therefore, this 6 low WPAN, that is IPv6 over low power wireless personal area network, adaptation layer addresses this aspect by enabling transmission of IPv6 packet over IEEE 802.15.4. So this your protocol stack, or you can say IPv6 over low power wireless personal area network adaptation layer, this adaptation layer, but it bridges the gap between this lower layer and this conventional IPv6 protocol. This adaptation layer also implements mechanisms for packet fragmentation, reassembly, among other functionalities. Similarly, physical layer, low energy communication at the physical layer. Mostly we are using IEEE 802.15.4 that we have already discussed. Network layer we are using your routing protocol for low power lossy network, that is RPL. Okay, and there are various issues for network layer such as energy efficiency, fault tolerance, reliability, network delay, throughput, buffer, availability, security. Those things also should be addressed, keeping in mind the application when you are designing routing protocol, or you are also designing some other higher level protocols. Application layer for IoT should be constrained. So that's why it is called constrained application layer protocol, which supports your communication among IoT devices. There are various types of operating systems or candidate operating system. I will just name it. If you are interested, you can go through them in detail. IoT devices are extremely low in power and memory and resources that we have discussed. Right now, an adequate or customized OS with kernel, networking, real-time capability, memory and processing, and more can make these devices flexible. When you design IoT system architecture, operating system in IoT, operating system designed for IoT devices based on architecture, scheduling methods, network technologies, programming models, power and memory management methods, right? So there are operating system. I'll name them. If you are interested, you can go through that. Contiki for the early development of wireless sensor network later, with a few improvements now is used on platform of IoT. Similarly, your TinyOS is another candidate OS for IoT devices. Riot OS is another one. Nano RKOS, Light OS. I'll be sharing the material. You can go through this. Okay, if you are interested in mostly OS, you can you further analyze or compare them, right? Mantis OS. So these are, if you are interested, you can go through these operating systems, okay, and if you systems, then you can compare, you can find out advantages and disadvantages among each other. Then the last part of my machine-to-machine communication. What do we want in IoT? In IoT, we want the machine must communicate among each other autonomously. Machine-to-machine refers to technologies that allow both wireless and wired systems to communicate with each other autonomously. So now, with least human intervention, devices must communicate and accomplish tasks. As I told you earlier, local decision and global decision. Now, if machine or your devices which are deployed in a given application domain, and they can do decisions, they must communicate autonomously without human intervention or with minimal human intervention. Okay, so that is what the requirement is. So that is called machine to machine. Some people say device to device communication, and some people say it is intelligent machine to machine communication. So machine to machine communications provide ubiquitous connectivity between devices. Devices have the ability to communicate autonomously, requiring no human intervention or minimal human intervention. Communication pattern may be device to device or machine to machine, device to human, and vice versa. Communication may be intra-domain or inter-domain. Communication can be with or without human intervention, as I told you. Right? There are different patterns exist. You can have single hop as well as multi. Single hop and multi hop based on the transmission range and all. Initially, I told you. So here also you can have each other via a network infrastructure, which could be an access point or base station through a single hop, an IoT device through a gateway. The data can be pushed, or you may need a multi-hop communication. There are various your M2M applications like smart grid, healthcare, various applications where this M2M, intelligent M2M communication required. If you classify based on the connectivity and all, then capillary machine to machine you have, cellular machine to machine you have. In the capillary machine to machine form a device area network wherein connectivity is provided through a short range communication, such as Zigbee and Wi-Fi. Whereas in cellular machine to machine, devices are equipped with embedded SIM card and have the ability of communicating autonomously with the cellular network. Okay. So if you are interested mostly on IoT research and development, there are some of the key technologies already I told you, and your aim must be designing lightweight protocols or devices to work together. So when I say lightweight protocols, why I want lightweight protocols? Because IoT devices will have limited resources, including your CPU, including your energy, including your memory or storage available in the devices. So therefore, they can't run high-end protocols, right? So lightweight protocols, including security or including secure protocols, lightweight secure protocols also you want, right? And you need cloud and fog computing platform. So to execute IoT-based tasks. Cloud is, we have discussed about cloud. You can treat fog as a localized cloud, where some of the cloud services are extended towards the edge of the network by the cloud service providers. Then more or less that is called your fog computing. So this cloud and fog computing platforms are customized cloud and fog computing platforms to be designed to execute IoT-based tasks. Bandwidth and energy efficiency issues must be addressed by designing protocols and designing applications as well. Okay, cyber security and privacy, these are the issues because most of the accessibility of the data, if some data is there in cloud, right? So anybody can access. Therefore, you have to restrict the access. You have to provide privacy of the data, right? And you have to provide technologies to prevent the theft of data and all those issues about the privacy, data privacy and all. Similarly, you have to provide access control mechanisms so that, as I told you earlier, in healthcare application, if a doctor can access data when he is available in hospital, right? Not when he is available somewhere else. So such type of things you have to also give access, not only password-based authentication to access some kind of data and all. So other attribute-based or other attributes you have to choose to provide access to various types of to provide access to data whenever required, and at which time it is required, from which location it is required. So such type of access control method you have to provide. Okay, you have to provide role-based access control methods as well as attribute-based access control methods for IoT data. Okay, so these are the few important references. Thank you for listening. Audience participants can ask some questions if they have.
Thank you, sir. We request the participants to ask few questions now.
I'll be sharing the materials, the PPTs. If you have any further doubt, also you can ask me later. However, if you have any questions,
Darshak,
Yes, ma'am.
is there any question in chat box?
No, ma'am, but I have a question, sir.
Yeah,
Okay.
Yeah. So basically, my question is, we have the heart pacers and all that. So what I read was when there is a problem or something which the pacer detects a problem, and it has to, send it to the cloud. Then the algorithm is run, and again, it is called back. But when you have to do the computation on the device, it becomes bigger.
Yes.
So how does but it has to be small, or else it would be hard to implement. And all over there. So how does that happen?
No, your question is that means your devices can't process that one, right? At device level, right?
Yes, sir. Because few algorithms, mostly machine learning, what I have understood is it has to be run on the cloud, only then it would
yes.
happen.
Now that's why if you listen my presentation, I emphasized on local decision and global decision, right?
Yes, sir. Yes, sir.
So now, based on the your availability of the resources, the amount of resources available at node level, you have to do some lightweight computation, and the other computation you have to upload to the you have to send to the cloud for execution. Then after that, if you are applying machine learning and all, you need some good amount of data to find out patterns, right?
Yes,
So
sir.
to determine patterns, you need, and when you are taking local decision, okay, when you are taking local decision, that time only you have data from one source. And when you are taking global decisions, then if you have deployed your sensor in a hospital, you are getting most of the data, right? Then
Yes.
if you have to take a decision as a whole. Suppose what is happening, not only individual patient. If you are taking a group of patients who are available in a specialization, okay, then you can take that decision there as well as if you want to take a decision about one specific patient, then you probably have to analyze data regarding that particular patient, or data for 1 year data for that particular patient, or you can say the past data of that particular patient. Then that you have to do at global level or cloud level, right?
Okay.
So therefore, you have to find out that how much local decisions should be taken, how much global decisions should be taken. Overall, you have to manage it, right? So we will say that locally, suppose you say suddenly the heartbeat is above 200, then immediately the locally itself there is some kind of customized message can be or alert can be generated, because locally the current your data says some abnormality, right? But if you want to your process that regarding the patient condition for last 6 months or 1 year, you have to give you have to find out some pattern. Only when he is running, he has health issues. Then you have to analyze some past records, right? Then only you can determine patterns. Okay, so therefore you have to, when you are designing it, you have to see what how much resources are available, which parameters, which are local parameters for local decision taking, and which are global parameters, and where the data can be processed, or which data you are going to process, or which kind of data you are going to process in the cloud, and how much data you want to process, whether it is 6 month data, 1 year data, and that again you need some kind of knowledge or specialized doctor's knowledge to do that, because those parameters, those doctor's knowledge required, right, to find out those abnormalities.
Yes, sir. Understood, sir.
Hello? Darshan?
Yes, ma'am. Sir, I want to actually thank you for enlightening us on IoT, which is actually the fastest growing technologies, and the session was indeed really helpful. We understood about the different sensors and networks and the various layers which are actually involved in IoT, and how protocols and network routing is actually helps us in developing network efficiently, and also then we also the sensor nodes, how they are actually connected uh, to the computing part via the network was really insightful. The session will surely help us design better IoT solutions and hopefully more in the biomedical field as it is the need of the hour. So thank you very much.
Thank you, sir. Rashmi, sir. Actually, it's very informative. Many times I have attended your session. Every time it is new learning, sir. Thank you, sir, for highlighting all the participants. It's actually very useful for all of us. Thank you, sir, for your valuable time.
Thank you, madam, and thank you, the participants, for listening. Okay, thank you all.
Thank you, sir. Even, sir?
Yeah, I am here.
Sir, I made you as a presenter, sir.
I have joined as presenter.
Okay, Pratisha? Pratisha, are you there? Hello, Pratisha?
Hello, ma'am.
Ah,
I'm here.
Could you please introduce Neeraj, sir?
Yes, ma'am. Hello, everyone. Our next talk is on the topic Sensors for IoT Healthcare by Dr. Neeraj Sharma. Dr. Sharma received his PhD in Biomedical Engineering from IIT BHU Varanasi. He has done his MTech in Instrumentation and BTech in Electrical Engineering. His areas of specializations are bioinstrumentation, bioimage processing, and artificial intelligence. He has 4 patents on his name and has published more than 80 papers. He has been a PhD guide for 8 students and is currently guiding 8 more. He has been a guide to over 60 presses at UG and PG level. Dr. Sharma is a lifetime member of Association of Medical Physicists of India and ISTE. It's our privilege to have you here, sir. Now, without any further delay, let's get into the session. Over to you, sir.
Thank you. Thanks, Madam Padma, for introducing me and providing me an opportunity to interact with the participants for this IEEE Summer School. So I will start with my presentation today. I'm going to share my screen. I think right now it is little on share screen option is not coming to. I want to share my PowerPoint slides. How can I share it from this?
So I made you as a presenter, sir.
So I have to join again as a presenter. Okay, let me try.
Ma'am, if you stop sharing and then give the presenter access to sir, he'll be able to do it.
Okay. Yeah, right now you may be sharing. Yeah, that's why I'm not getting the option. Okay. Still now I'm not getting the option. No, it's not coming.
Sir, only 1 minute, sir.
No problem, no problem. We can wait for a minute.
Yes, sir. Now you're the presenter.
Okay.
Please start.
Yeah, it's not there. So I will be sharing my screen directly. Okay. Yeah. Now, if you are able to see the, shall I turn off my camera?
Yes, sir.
Shall I turn off? Simply because it will be loading, I think.
So we'll take some photo afterwards. We can switch off, sir. Pratyusha and Sadia, all of you, please switch on your video once.
No problem. Let it. Otherwise, if it is coming on the screen.
Yes, sir.
Okay. Let me try from where I can switch it off.
Okay, sir. We have taken, sir.
Yeah, you can switch. If you can switch off my camera, you can switch it off.
You have to switch off, sir.
Okay, I will have to.
If you have bandwidth, okay, then no problem, sir. Even though you are sharing your.
Okay, no problem. Otherwise, it will. Okay, no problem.
No, okay, sir.
Okay, let me start.
Okay.
So,
Thank you, sir, for accepting our invitation.
Thank you, ma'am. Thank you. Welcome for your nice session. Basically, today we are going to talk about the sensors for IoT in healthcare. So, everybody knows that IoT is a field which is very fast developing, and at the same time, healthcare is also one of the most, you can say, the prime area where everyone, you can say, that needs to put effort. It may be from medical practitioner, it may be from patient point of view. The main motive is to achieve the good health index of the, you can say that people for which this sector is there actually. So I will discuss regarding the this very quickly, the basics of the IoT. I think the earlier presenter, Dr. Rashmi, has already discussed about it. So I will quickly go through this point. Then I will directly go to the what are the issues and challenges or the sensors in biomedical engineering, and from our own lab experience, what we have carried out in our work in our lab. I will be presenting you that mainly work which we have carried out. So this is going to be the flow chart of my presentation. Brief about IoT in healthcare, then case studies. We are going to take today the 3 case studies. Quickly, APIC sensor-based ECG acquisition, non-invasive glucometer, and application of IoT in sleep studies, and other possible sensors. So I will quickly go through what are the different ranges of the sensors that are available in instrumentation area and how they find applications in biomedical area. It's going to be an interesting from that point of view. So brief about the Internet of Things. Internet is basically the mean to connect all the people, and that is called as the Internet of the People. And IoT that connects all the things is called the Internet of Things. The main motive is to connect the objects, machines, sensors, actuator, mobile phones, electronic devices, and home appliances, and one web itself. The main concept is of this IoT of the things or Internet of Things is particularly, from my point of view, what I can understand is to assess the right information send it to the right place for the assessment or analysis. That is the second part. First part is the picking up the so you can say that information, then passing it to the right place, and then after analysis again what corresponding to that the right action is that. And so this in every place you will find that whether it's a you can say that automation, industrial automation, whether it's environment monitoring, you will find that the IoT application will be there. It's very fast emerging area because of the availability of the internet, computing devices that may be your mobile phone itself. So that is a very good, you can say, the features of nowadays the mobile is almost having features equivalent to that of a very good computing system. That that includes your computing systems in terms of a computer. It is having very good processor, very large memory, cache, RAM, each and everything is there. And because of this, the things have been made easy and easily accessible. You can say that the area of the networking and computing. So because of this very computational achievements and enhancements, we are able to realize this very growing up areas of Internet of. So Internet of Things basically finds applications in engineering, almost all of the sector, engineering, industry, infrastructure, transportation, health and medicine, environment monitoring, and whatever the sphere you can think of, you will find that you can find an application for IoT. And this is the graph which I have taken from the source partner, okay, and which shows how this is going to progress, what are the expectation and what is the slope of the, what are the plateaus and what are the issues in this very IoT and realization. So you can see that it starts from connecting home, biochips, data sciences. So it's all playing about the data and the sensors. So mainly two things are there, data and the sensor and the place to analyze this. IoT most important feature. So from my point of view further, I have included the most important feature of IoT is to include the artificial intelligence. That is the latest, you can say that area from last, you can say that 10 to 20 years back. The artificial intelligence is, you can say that finding application in almost all sphere of life, whether it's medicine, whether it's defense, whether it's automation, autopiloting, whatever you can think of the field, you will find that an application of AI is there. So AI in present case also need to be, you can say that very much there along with the IoT. Then artificial intelligence, connectivity, sensors, engagement. So these are the some of the key features of the IoT. And further, it requires small devices. That is the miniaturization of the devices is also needed. Devices and sensors which can be placed. Okay. So AI is essentially very, you can say that essential, going to be a very essential tool for the, you can say that IoT system, and lot many algorithms are appearing day by day, including your deep learning. Of course, the deep learning is having a little bit disadvantage that it is quite computationally expensive. Still, the people are finding the way to make it decrease its computational load on the system and time, in terms of system and time, the resource requirement and time. Then connectivity. Connectivity is another main requirement of the IoT system. Next, sensors. IoT loses its distribution without sensor. They act as defining instrument. Basically, sensors are the integral part of this very IoT system. Whenever we are talking about the IoT things, we need a sensor. It may be single type of sensor. It may be an array of sensor. So, many sensors and their integration is really needed. What is needed in the IoT? So, sensors part we are going to discuss in another way. Then active engagements, then small devices, then miniaturized devices, which are you can say that very less on power consumptions. They are particularly needed in healthcare sector. That is, whenever you have added the devices, the requirement of the power supply, particularly the why small devices and energy efficient devices, the power requirement is reduced. Whenever the reduced power requirement is there, a small battery, miniaturized battery can serve for very long hours. And here are some of the advantages of the IITs, which I have picked from the internet itself. You can also find this. So first main advantage is the technology optimization. Uh, Same technology that provides the data. Basically technology optimization. This means that the optimization of the resources, whatever the resources we are having in terms of devices, in terms of your internet, in terms of human resource, that is the expert, which is going to deal and analyze the data at the other end. Of course, AI is going to support this data analysis, but finally, it is the decision of the expert. For example, in medical field, we can never replace a medical expert. Of course, the system, whatever you have designed, are going to assist him in one way or another way, whether it's IoT, AI, or sensor integration, whatever is that. So finally, whatever the data has been analyzed, it will be presented to the expert, and in this way, your optimized utilization of the resources will be there. Effective utilization of resources I have already covered. Enhanced data collection. So modern data collection suffers from the limitations and designed for passive users. IoT break into those spaces and place it exactly where humans really want to go to analyze our world, whatever we want to analyze. So data collection is very, you can say that, fast, whenever fast and reliable. So at the same time, there are certain disadvantages of IoTs also. You can say the disadvantage is the security issue, privacy. Whenever you are having, you can say that lot many data is traveling over the wide, you can say that different networks, the security issue and privacy issues are certainly the main things. You might be hearing that daily that Google is stealing the data. Such type of things are also there. It is watching each and every activities of your. Once you log onto some, you can say that in shopping or in any area, it automatically catches what you are looking for, and it starts throwing that very messages and advertisement of that sort to you. Once you visit YouTube for one purpose, automatically upload the same type of video. So that is the how this you can say that big names like Google, Facebook, and these are or whatever the internet provider and these platforms are there, they are directly watching your each and every activity and accordingly manipulating it. Suppose you have gone for some on the website regarding some healthcare issues, so it will automatically suggest you the same type of, you can say that, websites and advertisements will be. That is the security and privacy. Then complexity. IoT system seems to be simple. At the same time, it is complex also from the point of view of the design, maintenance, and multiple technology involvement. So it involves the complexity also. Issues of the flexibilities are there. Compliance are there. Compliance issue means one platform to another platform, how those things are going to be there, how the regulations are going to be there. Software, you can say that many consider standard software compliance battle. That is different. You can say that service provider are, you can say that using different platforms and their compatibility, their cross connections is also needed. These are some of the disadvantages, or you can say that. So Internet of Things hardware, I think you've already discussed the previous you can say that expert has already discussed about this, so I will quickly go through. So IoT utilize hardware, sensors. So in this, you can place Wi-Fi, Zigbee, Bluetooth, radio transceiver, duplex, and BAW RF. So these are some of the hardwares which you can directly use when you are designing your IoT-based sensing system for any application, any of your applications. This one, Zigbee, that you can pick up for data communication. So directly such type of modules are available in the market. Then standard devices which you can also interface with you can interface program on Android platform or any other platform based on your desktop, tablet, cell phone, whatever the device you are having, digital device you are having, you can interface with the system. So in this way, the devices are there. Then Internet of Things technology, LTE, Wi-Fi Direct, RFID, NFC. These are all terms you can find it out. Select any technology for your application. Then NFC, RFID, and these are some of the, again, the same thing. Then low energy Bluetooth requirement, low energy wireless requirement. Better the energy efficiency of the devices, whether it's at the level of the sensor or it's at the level of your IoT, your internet based data transmitting system. So that will be, you can say that operate for longer time and lighter in weight also. So these are some of the then platform for implementing IoT, that is the software platform. Invox is there, GE Predix is there. This is the GE Predix module itself directly available, commercially available. Then Quantity and then Eclipse IoT. So these are some of the platforms, software platforms that are based for the that are available for the developers. Now let me come to the main topic of my area, that is the IoT in healthcare and medicine. So the RC basically pushes the medicine, pushes us toward our imagined future in the field of the medicines, which exploit highly integrated network of sophisticated medical devices. Now we'll have to look further. IoT is enhancing. Basically, it is capable of enhancing medical research. That is, whatever the research is going on. Mainly in medical research, what you need the resources, basically the clear diagnostic values. What is the problem that is pertaining? What is the diagnostic value? Then what is the data regarding it available for the worldwide scenario? There may be case that the same problem, for example, suppose if we have taken the, let me give a very basic example that only we discuss with the medical practitioner. Suppose an X-ray has been taken in India, in some region. And the same X-ray has been taken some region in other country. So if there is a patch or lesion within that, then most probably first our protocol will be to correlate it with the TB or any other thing that is available. So that depends upon the region to region. You can say that X-ray may be same, the intensities and changes may be looking the same, but the data for that region may be indicating some another reason, another type of problem. So medical research mainly depends upon the data which we are collecting, and also depend mainly widely from person to person. It is going to be different for different age group. In this lot many parameters are there. Age group may be there, the sex may be there, the race may be there, and the country of origin. So lot many lifestyle, lot many things are there which contributes towards the medical research and which medicines the patients are going to respond. So this all becomes a part of the medical research. And second part, IoT that is enhancing is the devices. So devices, I have just in the next slide we'll see what are the total, you can say the devices, how we can classify them, and which devices can be directly interfaced with this IoT and worldwide. Then care and emergency care. This is again related with this, what are the diagnosis values, what is the analysis of data, and accordingly what are the care plan or the action taken plan, or in case of emergency, what is the emergency care. So the integration of all elements provides more accuracy. So whenever we combine all these, you can say that the four I mentioned, medical research, devices, care, and emergency care. So this integrated platform, you can say that flow of the information provided more accuracy. And that means the better treatment and better health care providing to the patients or the person. So more attention, detail, faster reactions to events and constant. For example, in case of now, you might be seeing that in this very COVID scenario. Well, let me take the example of the COVID scenario. In COVID scenario, you can see that what is the role of the information. Uh, uh, Arogya Setu app is doing in that purpose. Whenever one is diagnosed uh, positive, COVID positive, accordingly, whosoever is coming into contact with that, so that signal, that information is shared on the platform of the very Bluetooth platform to one to another. And at the same time, you can see that what is the spread rate of the COVID and how and what way it is progressing. So as the virus is fast, so is our actions are needed to be very fast. And the recent strain that has been traveling from UK is 70% more faster. It's said to be 70% more faster in spread out in its spread. So accordingly, you can see that the role of the virus, it is fast at its end, and at the same time, we need a fast action at our end also. To meet this, the technology is needed to cope up. So, example in emergency condition, I have taken one example in emergency condition. What will be the benefit of this? That is the patient record retrieval. The system analyzes the new data and current data, whatever the patient background is there in who is in emergency condition. Accordingly, the new data and past data, past history is retrieved, and accordingly, that will be a guiding factor for finding out the solution in the case of medicine and medical diagnostic preparation and accordingly the treatment plan. These are some of the advantages of the IoT in healthcare. So I will just read the blue highlighted one. Of course, you can, I think I will have to discuss the features. We will little bit go quickly. So IoT system basically applied to healthcare and hence existing technology in general practices. They increase both accuracy and size of medical data through diverse data collection from large set of real worlds. Next advantages in the research, IoT opens the door to important and valuable information through real-time field analysis and testing. And IoT can deliver relevant data superior to standard analytics through integrated instruments capable of performing viable research. This aid in healthcare by providing more reliable and practical data and better leads for any condition. So which yields better solution and discovery of previously unknown issues. So for example, sometimes some issues may get hidden, but if the information is more about some disease, its spread, and its you can say that then it can be very well addressed. And the information from one point to another point can be sent very quickly. Then it at the same time avoid risk by gathering data without manufactured scenario and human testing. You might be knowing that in case of this COVID, how the vaccine has been prepared at a very faster rate. It has not been earlier that within a span of 6 to 8 months, the vaccine is ready. And before the human trial, the results we are visualizing and testing is done continuously. So this is able to avoid the risk of gathering data without the, you can say that directly going for the trial level, we are directly moving faster for the development of these using the earlier known techniques and standards, we are able to develop these COVID vaccines at a very faster rate. So devices that is regarding the current devices are rapidly improving in precision, power and availability. IoT unlocks the potential of existing technology and lead us new and better medical devices and solutions. So this I will going to take in the case study. So IoT closes the gap between the equipment and the way we deliver health care by creating a logical system rather than the collection of tools. It reveals patterns and missing elements in the healthcare. So now, IoT in healthcare, particularly in biomedical engineering. Biomedical engineering means when we are at the stage of the developing of the biomedical instruments for the measurement of the um, uh, human health and its parameters. So basically, this is the generalized diagram. You need sensors to pick up the information of the regarding the health. It may be the signal, it may be the physiological parameter, then some electronic instrumentation or signal conditioning is needed. Then signal, after that processing of that very signal or information, display system, storage system, and accordingly the feedback is there. And based on the feedback, your actuators, the remedial actions are taken. So the type of biomedical equipment or the measurements, we can classify into basically 5 or 6 categories. This includes your body signals such as ECG, EMG, EG. These signals are very important and give very good primary information about the working of the heart, muscle, and brain. And mainly you will find that the ECG and EG, these are the 2 primary areas in monitoring the cardiovascular health and brain health. Then after signal, physiological parameters. These are very important. You can say that in the first thing that a medical practitioner do is the analysis of the physiological parameters. For every healthy human being, there is a standard set of band of these values where the parameters are going to lie. For example, the first basic parameter is the temperature. Human body temperature is under normal conditions is 98.2 Fahrenheit, and of course with a variation from individual about 0.5 variation. Fahrenheit variation may be there. It may be 97.5, and it may be 98.6 or 8. Up to that, we treat it as normal. And temperature above this will be treated as, for example, particularly if it crosses the band of 99.8 or 100, particularly that one up to 99.56, again it's in the safe band, no problem. But the moment it crosses 100, that condition is diagnosed as a fever or mild fever. So that is the first most parameter. In the COVID area also, we are monitoring the temperature. That is the primary indication that there is something wrong, or some infection is there, some viral infection is there, or something wrong with the body whenever the temperature is there. Then second important parameter is your heart rate. Again, in the viral fever condition or that condition, the heart rate, normal heart rate may go up. It may go up from 95 to 105 or 110 or so, depending on the condition. And the normal range is from 65 to 90 beats per minute. Then another important parameter that we have been monitoring in this COVID area also, COVID time also, that is the SpO2, that is the percentage oxygen in the blood. Whenever some disease is there, particularly the disease that is affecting the lungs, the value of the SpO2 or the oxygen, the saturation in the blood is going to down. Then another important parameter is your blood pressure. So it is also needed to be within the safe limits and safe band. Then another parameter is your blood. So these are the physiological parameters for which we are having mainly primary diagnostics. Some devices are there, blood pressure machine, sigma-manometer. The primary standard is the sigma-manometer. Of course, electronic blood pressure measurement devices are also available. They need to be properly calibrated. Dial gauge type of are also there. And for temperature, again, electronics type are also there, and mercury base is also there. Then for SpO2, again, it's a pulse oximeter you can directly use, which will be also give you the heart rate also. Then nanobiotechnology. Nanobiotechnology is basically the analysis at the nano level or the chemical level. Then analytical instruments such as blood glucose. So we can include these third and fourth in one also. Analytical, such as your blood glucose and lipid profiles. These are going to be analytical. That is regarding the monitoring of the blood condition or the body fluid conditions. That comes under the analytical. For that, mainly spectrophotometers, colorimeters, and that type of devices are used. And then radiological imaging. This is also and functional imaging. Radiological imaging includes your X-rays machines, ultrasound, CT scan, MRI, and for functional imaging, mainly your MRI can be used as well as your positron emission tomography or PET imaging can be used. Then pathological studies. So these pathological means taking the biopsies and doing the identifying under the microscopic studies. So or growing of the bacteria in cultured medium and seeing the responses. Okay. With this, we can mainly divide these two groups. I have intentionally shown three different colors. So this you can see that measurement first, second, and third. Particularly first and second, we can have wearable devices which can be weighed and monitoring can be done. Of course, most of the time, whenever the accuracy and reliability is required, mainly the issues are the accuracy and reliability. We will have to definitely go to the you can say that hospital or lab for getting the diagnosis done. But still, these first two categories, we can have the wearable devices, so which we can monitor the health condition, regular health condition in our home premises also, or at workplace, or at our convenience also. For example, heart rate we can take at home also, SpO2 we can measure at the home also, blood pressure we can check daily by using the automated blood pressure machine, similarly temperature. At the same time, nowadays some devices are available which can pick up your ECGs also. Okay? So these, wherever the signals, electrode-based, you can say the sensing is there, we can pick up the signal and we can get it transmitted. For example, in holster monitoring of the ECG, that is the day long, this can be carried out by the patient, and miniaturized lightweight machines are there, can be interfaced and to find out this. So first 2-3 categories can come under the category of the basically wearable devices. Then particularly for radiological imaging, functional imaging, and pathology studies, the hospital is the best place, and accordingly the lab, hospital, and patient interfaces needed. And this will be going through this end: hospital, lab, hospital, and patient. So these three interfaces will be there. And of course, one area I have kept intentionally this, like blood glucose monitoring and lipid profile monitoring. This can be monitored in hospital also, or lab also, and can be monitored home also. And there is a requirement to monitor sometime continuously the blood glucose level. That is particularly in diabetic patients, highly diabetic patients, when what is the meal he has taken, accordingly what will be the dose of the medicine needed. It may be some oral medicine, it may be some insulin-based medicine also. So accordingly, both has to be, you can say that, correlated. So wherever the requirement of particularly the continuous monitoring is there, so that can be done. Okay, so this under the variable type of variable and lab base. Okay, in variable electronics devices are very small devices. Nowadays, you might be seeing that lot many advertisement is there over the you can say that different selling platforms at Amazon or Flipkart. You are finding that smart watches are there. Smart watches are available, which not to very good accuracy, but still they can give very good index about the temperature. So they are helpful in regular monitoring, watching your activity. They can watch your physical activity. They can watch your sleep. So all this I have included. So they can monitor temperature. They are capable of monitoring heart rate. They are capable of monitoring SpO2 also. They are capable of finding out the sleep analysis. They can also find out the condition of drowsiness while driving condition. And some are also claiming that blood pressure can be measured, but from blood pressure point of view, it is not very accurate. However, still temperature, heart rate, SpO2, and sleep analysis, these four, these can measure very good way and reliable way, and very close to approximate, which can give you a fair idea about the conditions. So the main features that must be focused in IoT system design from biomedical point of view. These are accuracy, simply because whenever we are dealing with the medical data of the patient or medical healthcare condition monitoring, this is the first and the prime most requirement. For example, if some I have weared some you can say smartwatch and or some wearable device for oxygen saturation monitoring is there. It is suppose my normal is 98 or 90, it's 97 or 90, 98 suppose. If there is an inaccuracy of 5%, that means the data will directly go to 92 and 93. That shows, and 92 and 93 means that there is some underlying cause for in the lungs, that maybe the person may be infected by the COVID or any other virus which are affecting, or pneumonia which are affecting the lungs. Accuracy is the prime most. Same is the case with the body temperature. 98.2 is the normal. If it is there in inaccuracy of 2%, it will be directly 100.2. So you can see that the slight variation of 2% or 3% may give you very considerable variation in the result, and analysis may differ in that case. Accuracy is the prime most requirement. Then reliability, safety, and security of the patient. So these are the four main requirements from IoT point of view. And next, I am going to take the case studies. So this case study I have taken about the wireless dry sensor for mobile-based ECG and cloud-based remote consultancy platform. This we have developed in our lab in 2017 along with our industrial partner, that is Pravartan Technology. And from there, project coordinator was Mr. Manish Srivastava. He was also the founder of this very Pravartan Technology company. Then, from our team, my student Soumya Srivastava was there, and presently she is doing her PhD from ISC Bangalore in the area of biomedical engineering. Vancouver's Vivek Singh, he was my IDD student, myself, and other two investigators, Radha Kumari, Manish Srivastava. So this was our team, and we have worked for the wireless dry sensor for this. Now, what is the concept? These are the standard ECG lead configurations. We can place electrodes on right arm, left leg, and right leg we treat as a standard, you can say that reference point or the grounding or earthing point. Then total 6, you can say that electrodes we can place on the test V1, V2, V3, V4, and V5, V6. Okay, so total 12 leads configurations are there: lead 1, lead 2, lead 3, AVR, AVL, AVF, and then V1 to V6. Okay. So let me first show you the Apex sensor. For this, we have created the architecture and block design of the dry wireless sensor. That is, for this application, we have used the Apex sensor, which is a capacitive light pickup. And advantage of this, we are having two types of electrodes to pick up the biomedical signals. One is your AG, is popularly used is your disposable type AGCL electrode. Another is the limb electrode. That is, you can say the plate-based electrode to pick up the signal, limb electrode. Instead of this, we have gone for the Apex sensor. The advantage of the Apex sensor is that there is no need to directly for this device to come into with the contact with the body. Even if you can place it on the shirt also, directly on the chest. You can say that on the cloth also it can be attached to pick up the signal. So it is a very dry type of electrode, no electrolyte or gel is needed. It has a very good capacitive pickup and a very high impedance, so the chances of micro shock and shocks are also, you can say that, virtually eliminated. Exactly. So for this, we need the front-end architecture, that is AFE, is based on the following. We have designed regulatory power supply. Power supplies can be replaced by your miniaturized battery. Also, electric potential, IC epic sensor, instrumentation amplifier, and that filters, low pass, high pass, and notch filters were added, and bypass for level shifter, and ADCs were added for the converting that analog data into digital data and then transmitting it to the other point. This is your epic sensor. This is particularly for development of this full this dice sensor. We have used this one. This is module is PS25253 by Classy. So this is having become the VDD VSS ground, and this is the output pin, and these are some of the test points that keep isolated. And this was mounted on the, you can see that PCB-like structure which we designed in our lab and fabricated to house this very sensor. Then this is the power supply, regulated power supply, which we have used to provide to this one. Simply because whenever you are dealing with the ECG, picking up the ECG-like data, so the DC, there is, you can say, no baseline shifting. To avoid that baseline shifting, your power levels must be maintained very, you can say that, stable. And this is the block diagram of the ECG acquisition system. You can find this, and you can say that most of the block, you can say that schematic for picking up the ECG signal are by and large the same everywhere, all across the world. You are having epic sensors. Here we have replaced our EEG sensor by epic sensor, or the standard electrodes have been replaced by this one. Then instrumentation amplifier is there. High pass filter, low pass filter, notch filter, USB data acquisition, and then it can be interfaced with the computer or with your mobile or cloud computing for the data. Just a minute. Let me have. Then next, this was the schematic diagram which we have developed. If needed, I can show it to you. This includes most of your sensor operational amplifier. For this, we have used OP07. It is the FET-based amplifier. Then to this system, we have designed the input buffer and the respective filters, and the output was designed to data acquisition system or Arduino that we have used. Okay. So next, these are the waveform that we have been able to pick up. This is the raw ECG waveform, that is without the, you can say, the adding of the filters. Then this is the waveform after filtering. That is, we have intentionally added some of the noise, 50 Hz noise. Of course, we could have avoided this also, but from the testing point of view, we intentionally added the noise by switching electrical appliances nearby and taking the reading and seeing what is the, how much filtering we can do or carry out. What is the signal to noise ratio we can get best for this very application. Data from DIC sensor, notch filter, and we have used it at the hardware level also, and in the software level also. We have done filtering in the both way by using the hardware design notch filter as well as by you can say that digital filter also. We have tested it in both ways and got almost the same result. And this is the how we have tested this. This is the digital CRO. This is the circuit which we have fabricated for testing in the. This is the under when we tested on the breadboard condition. So you can see that AG cell electrodes are here. Two AG cell electrodes are there. At the same time, we are picking up this signal, ECG signal through the epic sensor just by placing the thumb. You can see that how much advantageous is this epic sensor is that it can pick up the signal even by slight press of the thumbs also. So this is very, you can see that added advantage of feature of this very epic sensor. So both the signal by using AGCL we are displayed on the CRO, and we almost get the similar responses in both the way. So these are the specification of the sampling frequency and settings which we have carried out in method analysis. Both the wave were taken and the complexes, K versus complex were compared, and from that we you can see that and done a comparison between the two LEDs. And you can see that the foil is there. The role of this foil is to you can see that reduce your static current. This grounded, and the static voltage, whatever we are going to take up from any system, that reduce. Earlier we were trying without this also, and we are not getting. You can see that a lot of noise was there from the surrounding and region. Once we use this, this was helpful in this foil was aluminum foil was helpful in reducing the noises level also. And of course, at later stages, you can use if it is a cable.
Sir,
Yeah.
seriously, can you keep presentation in F5? Please press F5.
Presentation in
F5, sir.
F5 means
Full screen, sir. Presentation mode.
presentation. You are not able to see. It's a full screen mode. Full screen mode.
Full screen mode, sir.
Okay,
Yeah.
okay. No problem. I can do that. But yeah, basically it was because of the control. Yeah. I
Okay,
think
sir.
it's,
Thank you,
it's
sir.
no problem. So this was the case, and these are the signals. Okay. No problem. Thank you for informing me. So next, this is again the same which we have used. We have then used with this with the very power supply of 9 volt batteries, and still the results are better. The 50 Hz noise was very much reduced by using dry sensor and AG cell. Both we have done the comparison. And these are the waveform, raw waveform that we got from using dry sensor, and the waveform baseline bending correction was carried out, notch filtering was carried out, and this was the final waveform, and very good results were there using this very sensor. And this can be very easily, since its power requirement are very less, so it can be directly converted in wireless picking up as a wireless method for picking up the signal. And this is one. And final outcome. The final outcome of this very project was the system can operate in real time, in real mode. The overall signal quality that was achieved in this was very good. And contact measurement showed clearly that the epic sensor can reach the ECG quality that is at the diagnostic level. So advantage is clearly what we have got is the price AGCL. It was the results were equivalent to that very AGCL. The non-contact measurement results were also surprisingly very good, especially when measuring through the thin t-shirt. These are the some of the 2 points which I can just give. Traditional electrodes we can replace it. And this was the end product design which we have carried out. This was the variable. You can say that variable conversion of this very baseline on this base. This was having this and fitted in this very module. Okay. This is again the same appendix we have already discussed. This is the pin diagram. This is the internal circuitry diagram of this very epic sensor module, and advantage of sorry EPIC module is that its resistance is very high, that is 20 giga ohm. It's really advantage. You can say that from this point of view. And dry contacting capacitive coupling inputs. So these are some of the specifications. It can operate from 2.4 to 5.5 volt plus minus. And this is its very typical body plot of this very topic. So regarding this, I can tell you 2-3 things which we faced. Let me, if time is sufficient, then I can tell the real challenges that we face. Not only myself, but other faced. Yeah, these are my mails regarding this. Another professor, Ananda Shastri, was in US, was working on the same EPIC sensor project. I'm just can increase its size. You see, the challenges which we faced while fabricating the EPIC sensor. My name is Ananda Shastri, physics in Minnesota State University. I ran across your paper, this one, and was integrated. We are experimenting with EPIC sensor to monitor ECG, and I have question particularly. And he faced problem that initially the circuit seemed very stable. However, after scraping with the solder and flux, with the toothpick cleaning it with the alcohol, the trace stabilized and read ambient noise. Moving a hand inside the Faraday cage, still they were not able to get the solution, and lot many noises were there. So in your paper, you has mentioned that what the difficulty they faced, and in our paper they find that everything is okay. So he asked for advanced suggestions, and that from that I advised him how to move, what to move, particularly the temperature of the soldering. It was needed to be less than 200, simply because it is also the static charge sensitive device which can damage it, and temperature needs to be very low. Low level soldering is done. For that we have used weak flow soldering. We ourselves tried at least 3 to 4 months to achieve the results of this very sensor. And after that his problem was solved. This is to just to let you know that the method worked for us, and thank you once again. These are some of the issues which we sometimes see that working with the miniaturized sensor and faced with this type of issues. But eventually, when we keep on working and keep on moving and trying different strategies, we find that we are able to address the issue. Okay, let me come back to this. Now, the next is the non-invasive glucometer. So, glucometers are available in market, for which some minimal prick type methods are there, or blood drawing methods are there, which we can pick up the, you can say that drop the blood and we can measure the blood glucose level. So, these invasive methods are little bit, you can say that painful, high recurring cost generation. So every time sample has to be taken, and there is chances of infections also. Okay? And particularly in diabetic patient, the chances of infection is still more. So, so that's why we got inclined toward the non-invasive method for the blood glucose measurement. Of course, lot many people have also tried it, and I will show you their review also in what were their limitations. We will remove the shortcoming of present-day techniques and possibility of better quality of life, that without tracking, reduction in complication and mortality associated with the diabetes mellitus. And finally, this is the very important point, continuous monitoring will give better control over the diabetes. Particularly in diabetes, sometimes hyperglycemia is there, sometimes hypoglycemia is also there, which is very dangerous condition. From that point of view, the continuous monitoring will definitely be better and will give an advantage over this very conventional methods and techniques. These are some of the, you can see that reviews of the earlier non-invasive glucometer and their working principles also I have shared. This was a gluco track by integrity application. It utilizes the ultrasound, electromagnetic thermal technique to detect blood glucose in non-invasive. Then non-invasive glucometer by Globe instrument. It utilizes patented optical bridge technology under infrared spectroscopy to detect blood glucose level within 20 seconds. And microwave-based non-invasive glucometer. So this is work on the particularly the interaction of the microwave and their patterns with the blood glucose level. Then NIR optical spectroscopy. The optical technology is tools were used in a manner to eliminate the background noise and focus on the glucose molecule especially. A non-invasive glucometer based on light technology, based on Raman, based on the Raman spectroscopy. Then iSugarX non-invasive glucometer, this was based on the degree of the fluorescence produced due to the glucose molecules in the watery solution of human eye. Then contact lens continuous glucose monitoring. This device measures the glucose level in tears through spectroscopy method and wireless. Mainly you can see that some are utilizing ultrasonics, electromagnetic, and then infrareds have been popularly used, Raman has been used. So we also decided to plan something in between by using infrared and this very ultrasonic. So we tried a combination of these two. Now before that, interaction of light with the tissue. These are possible phenomena. In which light can interact with the you can say glucose molecule. That your reflection, fluorescence, absorption, tissue scattering, vibrations, transmission, and Raman phenomena can also there. So this will be these are the possible, you can say that interaction, and on that basis, these are the possible technologies that we can apply. NIR spectroscopy, MIR, mid-infrared spectroscopy, Raman spectroscopy, photoacoustic method. This is also very popularly used, and one researcher from IIT Jyothi was working on this very photoacoustic spectroscopy. Then optical coherence tomography, optical polarimetry. So these are there. For this, what we have done, we have first carried out the wavelength selection guide. What are the optical windows that are available and which of the better absorption will be there. So water absorption profile, melanin, optical windows, this so different from, we collected from the different resources also and included and compiled in this one. At the same time, independently, we also verified this data using our spectrophotometer available at the lab. What is the absorption spectra that for the glucose level of different concentration we tried to measure and find out where it is responding with respect to the wavelength. So you can see that at top you can say that maxima is there around 940 nanometer of wavelength, and you can say that from this band to this band the results are good. So that's why we selected later the 960 nanometer, that was the readily available near infrared LED light source for this very application. So these are some of the applications that 40 kilohertz results, 40 kilohertz ultrasound frequencies. So this is the literature review that what we can do with the 40 kilohertz, how it can interact with the tissues and internal fluids. And based on this, we designed this very module comprising square wave generation was there. So what we do, we generated the standing 40 kilohertz ultrasonic wave and given this to the fingertip. At the same time, synchronizingly infrared light was given through detector. This was the finger holder. To this ultrasound signal was given modulating signal, modulator, carrier wave, and the modulator wave is because of the same frequency that we have used for the switching of the you can say that infrared light source. So that signal later in transmitter and receiver of optical transmitter and receiver get modulated at this point. What is there? From this side, the ultrasonic was provided. On these two ends, the optical source was there. So with this, the standing wave was created, and that standing wave pattern was decoded by using the 960 nanometer infrared, and that information get modulated over this, and this was in response to the particularly the level of the glucose level. So accordingly, we did the Fourier spectrum of this, and then from Fourier analysis, we were able to extract the values of the glucose level using empirical formula. We derived an empirical formula. Standing wave generation, ultrasonic receiver was there, ultrasonic transmitter, for which with this, then infrared light source, infrared light detector. Basically, this comes in the you can see the pair itself directly, so you can directly. Then signal amplifier, and this signal acquisition, and from this we detected this information by signal processing in Fourier. This is the setup that we have used. This was the finger holder. On this side, ultrasonic sensor was there. On these two sides, LED and J detector pair was. And this was the testing and validation. We did it through the OGTT, oral glucose tolerance test. We did this on 30-40 volunteers of different age groups. That from starting, and this is the time lapse, glucose was given, and how this profile rises up, and then this comes up. And this was calibrated with the help of the standard glucometer also. So this is non-invasive method, and this is so invasive. The red one is the invasive glucometer levels, and this is our non-invasive glucometer level. But the limitation is that this is working only up to the this device which we have designed is working up to the glucose level of 200 mg per dl. That is in the pre-diabetic band only. So after that, again, some more exploration is needed at our end. We are trying, and thank you. The next application I can quickly take is the application in the sleep testing. Yes, application of you can see that IoT or sensor-based things. Where this I am going to take as a you can see the generalized study, and then we can analyze or discuss with the participant what other devices we can place in analysis of the sleep testing. Sleep testing, basically, you can do it with polysomnography, where sleep stages, respiration, electrocardiography, leg movements. So from this, we can analyze that. It's needed for evaluation of insomnia in certain situations, specifically when history suggests sleep apnea or periodic limb movement disorder is there, particularly restless leg syndrome or restless leg movement type of disorder is there. Sleep apnea, particularly in obese people, that is more despite get shocked, and because of that, you can see that respiratory system get shocked for a while, and that person or the patient wakes up because of this very non-availability of the oxygen to the body. Then multiple sleep latency test, daytime study, measures time to fall to sleep and enter in REM. Then 4 to 5 nap actigraphy, that is now available in the watch measurement with the wrist watch like devices that records movement. I think my battery is getting low. In stage 1 sleep, we can divide into 2 types: NREM, rapid eye, non-rapid eye movement, and rapid eye movement sleeps. So stage 1 is 5%, that is transition between the wakeful and stage 2 condition. So different stages are there for the sleep, which we want to intend to analyze through our, you can see that, sensor equipment. So regarding this sensor is also there for this very. So integration of the sensors can be done we can measure PCO2, PO2, SpO2. All this can be measured. Then EEG we can pick up to analyze the brainwave while in the sleeping condition. Then EOG electrooculogram to measure the rapid eye movement section or REM sleep. Then EMG for muscle tension. Then this is how the sleep studies are done normally in the labs, sleep clinics. And these are the EEG, EOG, EMG, movement of the legs recording is done, airflow movements, how the air is flowing through the nostrils, that can be recorded. Okay, chest wall movements can be recorded, abdomen movements can be recorded, nasal cannula can be detected, then SpO2 and also the levels can be detected. So you can see that how many sensors we can integrate for the sleep analysis. You can integrate EEG sensor, you can plan for it. You can include EOG sensor, again electrode has to be replaced with tension electromyography, then leg EMG can be done, or leg movement can also be recorded through the camera also. Airflow movement by using a thermal sensor and nasal cannula and pressure transducer, that can be done. Respiratory effort measurement, how much effort is going there in respiratory, you can say for the respiratory cycle. And pulse oximetry, that can also give a very good idea about the situation SpO2 levels. Then snoring can be measured with the help of the microphone. Electrocardiogram can also be done. Body positioning can also be done with the position sensor. You can see that whole bunch of sensors can be integrated for the analysis of the sleep. And other applications include nanobiotechnology level. I'm just quickly going through. So, the cytoplasm, this is a ultrasonic probe, independent design, and can be integrated with any of your laptop, computer top, the globally viewed AD system. And ultrasound can be done and data can be sent out. Then other sensors that we can integrate are accelerometer, magnetometer, acoustic sensor, pressure sensor, humidity sensor, temperature, proximity, image sensor, light sensor, microflow sensor. So these are the sensors, some of the sensors which we can find applications in your IoT areas. Strain gauge. I will take one example of the strain gauge itself right here. Force measurement, load cells, pressure. So these are the devices which we can measure with the strain gauge. Strain gauge technology in medical field. The medical infusion pump, kidney dialysis machine, fluid flow rates. All these can be monitored with this very device. So this is for the dialysis machine. This is for the infusion pump. You can see the diagram of the two infusion pumps. Flow rate monitoring, so this can be. So apart from this, tactile sensors or touch sensors can be designed. Then infrared for measuring the temperature. Okay, so with this, you can say let's stop here right now. And these are some of the references. Any question from your side? Thanks to participant. Hello.
Thank you, sir. Participants can ask questions now. They can take the question.
Yeah, actually my laptop battery is quickly draining out and I'm out. And so you can ask quickly. So any question from participants?
Prashant, Pratyusha, are you there?
Ma'am, Pratyusha has a small connectivity issue.
Darshan, is it Darshan?
Yes, ma'am. Sir, there's one question from my side.
Yeah, definitely.
Yeah, so you told us about the EPIC sensor, the dielectrode sensor.
Yeah.
I've gone through how ECG works with the wet electrode, but what I understood about the wet electrode was the whatever is applied, it is to reduce the impedance and all. Yeah. So here, when I saw the epic sensor and all, I just got doubt. Is there a possibility of us getting, I mean, the sensor detecting noise due to the movement of the patient or something? Because this is
Patient do not sense directly motion artifact. If you want to ask about the motion artifact,
yeah, motion artifact is a problem, is what I thought. Is it?
yeah, motion artifact can be eliminated by, you can say that, marking some position sensor, miniaturized position or acceleration center type of sensors are there. They can be integrated with your device, but of course, for that you will have to need some, you can say that, things which you can incorporate in the sensor itself. For example, if you have seen the cup design which we have used is a vacuum cup type, slight vacuum cup type of sensor is there, which can be sticked and glued at the position itself so that the motion effect is minimized.
Acha, okay, yes, sir. Got it.
Motion has to be avoided by any way. But whenever the relative motion is there, motion artifact will always be there. It is, you can say, that very hard, you can say, that thing to be dealt with.
Okay.
I mean,
So it depends on the design of the outer structure.
yeah, you can design, you can use.
Hello?
I guess sir is not connected.
Sir, I think sir has network problem.
Yes,
Hello,
sir.
Peter, sir? Okay, we have next session at 2 o'clock. Okay, all the members are requested to join for the session at exactly 2 o'clock. Hello, Neeraj sir? Hello, sir?
Ma'am, sir mentioned that he had a problem with the battery. I guess that was that.
Sorry, so once we will wait for 1 minute. అయ్యా థ్యాంక్స్ అదే పెట్టేస్తాను మొమెంటంలో మీ తర్వాత చేసుకోండి వాళ్ళు అట్లా అంటే కుదరదు పోలేదు పెట్టేసాను నాకు బాగుంది కలిసి కొద్ది Hello, ma'am. Hello, Vignana, ma'am. Yes. Good afternoon, ma'am.
Good afternoon. I just logged in because just to be there, I know my session is 2 o'clock.
3 o'clock, ma'am. 2 o'clock.
2 o'clock, yes. I just logged in to make sure everything is working on my computer.
Okay, ma'am. Okay. Thank you.
So is nothing going on right now?
No, just lunch break, ma'am. At present.
Oh, okay. Fine. So what I will do is at 2 o'clock after I finish at 2:45, maybe something at that time. If there are any questions, I can.
Hello.
Sorry?
Up to 3 o'clock.
Correct. I will take, but then I will leave 5-10 minutes for question and answers. Do people have question and answers?
Very few, 1 or 2 they are asking, ma'am.
Okay. Fine.
Okay, ma'am.
And sharing the screen, how do we share the screen? Not. You will enable that?
I have given permission, ma'am.
Right now I cannot see the share button coming on. It's so I cannot share my screen right now.
Now can you see now, ma'am?
No. It's coming as there, but I cannot take it.
Is it okay, ma'am, now?
No, not yet. Oh, yes. Yes. Now it says I can present if I want to.
Okay, ma'am, okay.
Are you able to see my screen?
Yes, ma'am.
Okay. So how many people have been attending? How many people have been attending?
Hello, ma'am. Actually, 100 people are attending. Some people through WebEx. We are streaming online also. YouTube.
Okay, okay.
Madhvi, the students.
Good afternoon, ma'am.
Good afternoon.
Yes, sir. Yes, ma'am. We'll get started because it's 2 already. So, welcome back, everyone. Our next talk is Cure is Inside the Patient, Biobanking for Healthcare Solutions by Dr. Jyothi. She is a truly inspiring personality. I'm happy to introduce her to you all. Dr. Jain has done her bachelor's in biological sciences from Delhi University. She did her MSc in plant breeding and genetics and received the NET fellowship and the overseas research student bursary for pursuing her PhD at Cambridge University. She worked as a research fellow at Vertex Pharmaceuticals, where she had a proven track record in leading multifunctional cross-site research teams. Dr. Jain has co-founded Sarum Sciences and Sapiens Biosciences and is currently the CEO of Sapiens Biosciences and Sarum Sciences, which are now sister companies engaged in biobanking and personalized medicine. Thank you for accepting our invite, ma'am. Please get started.
Thank you very much for having me. I know your audience is very much electronics and electronic engineering people, and so I will focus on areas that might be of interest to any of you. And if I don't cover something that is of interest, please feel free to contact us. I'll share our email at the end. Also, if you have questions at any time during the presentation, just drop them in the chat box, and I have left at least 10 minutes at the end for answering all of them. So thank you again for having me. So what I'm going to talk about today is something probably new for most of you. This area of biology which is called biobanking. And this means collecting small amounts of biological samples, which can be tissues, blood, urine, bone marrow, even tears. And this area is called biobanking. And we are India's first, largest, and across India, pan-India network of biobank. And we are the first commercial biobank. And the title is also related to that. Why do we biobank these samples? It is because these samples that would otherwise be discarded actually carry clues about the disease inside the sample and inside the data. So I will speak about how we have collated these samples and give you some examples on how we have used them so that you get an idea about why one considers that the cure is inside the sample itself. So this title actually I lifted from India Today article in which we were covered, where they called it Precision Medicine Finds a New Mantra, Cure is Inside the Patient. And this is back in 2017 when we were covered. And it was for the fact that we were banking leftover samples, leftover from surgery, diagnosis. And these samples then were being used for research and development of new healthcare products. They could be drugs, they could be drug targets, they could be diagnostics, they could be AI or ML-driven algorithms to predict who is going to respond to which drug, and many such applications. And so I like this title and I chose to use that for today's talk. So what is a biobank? Why are we biobanking? A biobank is merely an organized library of human patient samples along with the matching data. This is a basic definition. Time magazine in 2010 called it one of the 10 most important ideas in the world. On the left-hand side, you can see it says biobank, saving your parts. So a biobank does not save these parts for automatically putting it back into a patient. Many of you may be thinking of stem cell banking or cord blood banking. Those are some kinds of biobanks. We don't do that. Ours is a research biobank. The samples that are stored can be surgical waste tissues, such as what is left over after cancer surgery. It could be blood, it could be serum, plasma, urine, bone marrow, tears, as I said, any kind of human biomaterial that would be required to be given for some diagnostic or surgical purpose. As a business, it's a very large market. The worldwide market is pegged at $60 billion, and it's been growing every year at 5 to 7% cumulative annual growth rate. What is interesting is that the demand for these biospecimens and the services associated with them far exceeds the supply today. So there is a need to have such organized biobanks. The impact that they have is that they reduce cost and time for people to test new hypotheses in new drugs and in new diagnostics by testing in patient samples what you would otherwise test in human beings. So it spares animals, it spares human beings, and the cost of failure is much lower than if you were to fail in actual animals or in human beings. So I'm taking you back to 2010, where we were proposing to start this company. I am a first-time entrepreneur. I don't have a history of entrepreneurship in my family. So we were very careful and we were planning a lot as we were planning this enterprise. So back in 2010, when we started to think about it, there was no biobank of any scale that kept data from Indian patients, the risk factors, the diseases, the outcomes, treatment. And as I mentioned already, globally there is a lack of patient samples and services needed by R&D companies. The impact of the problem was that in India, we were adopting Western diagnostics and drugs without confirming whether they are equally efficacious and safe for our patients. We also are not optimizing treatments for cost and effectiveness. And we are also losing this large business opportunity for providing biobank services. So our solution was to create a pan-India biobank that covers all diseases. And for this purpose, we partnered with Apollo Hospitals. All of you know Apollo. It's a high-quality hospital network. We procure samples ethically with matched medical data. We then curate, digitize, and structure this data. So normally the data in patients in hospitals is very scattered. It's in some patient file, it's with patients, it's with some radiology department, some of it may be in IT, but it's not kept as a single longitudinal structured digitized data. This is something that we in the biobank do. And very importantly, to protect the patient privacy and identity, we code the data, so that anybody who gets samples or data from us cannot find out who it came from. So now I come to Sapien. What is Sapien? Sapien is a global biotech company that employs human translational platforms for the discovery and development of novel diagnostics, biomarkers, and drugs that should have better clinical outcomes because they have been tested in actual patient samples before getting to the clinic. For this purpose, we have built a systematic archive of ethically approved and ethically procured samples and linked data. We use them for disease modeling, understanding risk factors, target and drug discovery, but we do not use them to transplant it back into a human being. So we are not a cord blood bank, we are not a stem cell bank, we are not an organ bank. All our samples are used only for R&D. So this is a few years old slide, but this is to show you how Sapien is laid out. So our partner is Apollo Hospitals, and it is only one of the partners. We have other hospitals that are partners as well, and we are open to offer biobanking experience to non-Apollo hospitals as well. So please let us know if you are interested in working with us. Apollo today has 71 hospitals, and has very high number of patient footfall. It has very good diagnostic labs. And to this infrastructure, we added a biobank, a central repository that has large number of sample types that are across many different diseases. As I mentioned, we have a very strong database which has rich data sets for patients for whom we have samples. And we have expertise in developing diagnostics, and our background is in pharma. As Sadia mentioned, I came from Vertex Pharmaceuticals. And a partnership with hospitals also allows us to help commercialize diagnostics that come out of Sapient or our partners. So it's a very powerful combination of hospital and research that is, in a way, from the patient to the patient. So this is our footprint. It is a pan-India footprint. And this is since last 8 years that we have built partnership. So our headquarters is Hyderabad, right here. And we also have people present in Chennai, Kolkata, Delhi, and very soon in many other sites. And so we have ethical approvals from all these sites, the pan-India network. And we also collect samples from many sites. I was awarded the Women Transforming India Award in by Niti Aayog last year, this year actually, March 2020, it's almost becoming last year. I also won the TAI Hyderabad Award for Women Entrepreneurs. And last year, Sapient was selected to represent India in the healthcare category at the Global Entrepreneur Summit, Netherlands. So we won many different awards and been covered in social media, etc. So given this pan-India network, the samples that we have don't have any regional bias. So it's not like we have samples only from Mumbai or only from Delhi or only from Hyderabad. We have a lot of diversity in both sample type, ethnicity, and also disease type. So the diseases that we cover are shown in the left-hand side, the pie chart. And on the right-hand side, since a lot of personalized medicine initiatives focus on cancer, the right-hand side pie chart shows you the distribution of different cancers that are prevalent in India. So breast is very common, head and neck is very common, colon and digestive system is common, and to a large extent brain and neurological, and then gynecological reproductive system cancers. The data that we collate with each sample is shown here. We comply with all ICMR guidelines. So our business model is this. We have access to entire Apollo network. We also have partnered with QNRI and a few other hospital networks are in progress. So this is where we obtain samples and unstructured data. We work with many technology companies and other service providers to characterize these samples. And then within the biobank, we have structured data with the samples, all well cataloged. We have many R&D products, platforms, and services, a few of which I will share with you. And then we build images, omics, and data analytics using these samples. So what do we do with them? We then provide services and products to diverse clientele. These could be pharma, biotech, companies that are making biosimilars, diagnostic companies, many companies that work to make antibodies or pathology equipment. These companies are also our clients. Of course, AI, ML, nutraceutical, herbal extract companies, many companies. And when we develop diagnostics, we in turn offer them to our partners such as Apollo and others. So it's a highly leveraged business model where certain things we procure, certain things we give using these samples to maximize their utility. So this is a very busy slide. I'll just walk you through it briefly. So the kinds of services and products we offer are shown here. On the very bottom are leftover blocks. So every hospital that does surgeries, after the surgery is done, that tissue goes to the pathology lab. They will cut it into small pieces. They will use that for diagnosing the disease. And then they will store those blocks for some period of time and then discard them. So this is what is called remnant FFPE sample. This constitutes the bulk of 2 lakh cases samples that we have. So this is the basic diagnostic data, whether this came from a person who had chronic liver disease, or whether it was a breast cancer patient, or it had some kind of psoriasis, different kinds of diseases. Above that come cancer samples. So a lot of our work is focused on cancer. So we have further elaborated the cancer leftover sample with treatment and outcomes data. So what was the patient treated with? How were they diagnosed? Whether they responded to the drug or not? Did they have recurrence again? If they had recurrence, how were they treated with recurrence? This is called treatment and outcomes data. Then for many clients, we procure samples as they want. So it's not in our biobank, but we will go out and procure them if it's possible. For example, we work with a company that was looking for samples from patients who have fever. The fever could be because of dengue or chikungunya or malaria or other kinds of things. And so they're looking to develop a diagnostic that can distinguish between different kinds of fevers. So we went and worked with certain hospitals that would have access to such samples. Above that come in-house services. So this is where, with our cell and molecular biology background, our pathology expertise, we use these samples to do some work for clients. And I'll show you examples of that. Above that comes rich data and images. This alone is a very valuable piece of Sapient. So we are creating a digital library of FFPE samples, where once they have been stained with a dye or with HNA, we scan them in a high resolution scanner, and we are creating a library of such images. This is very useful for people working on machine learning and AI to understand how the disease progresses. Then we develop clinical diagnostics, as I mentioned, and we are also getting into genomics. So as we go from the bottom, where it is really leftover samples with basic diagnostic data, to starting to create richer data sets, diagnostic, services, omics, there is an increase in the value of the sample because it's being used in multiple ways. And the amount of data that we generate never can get exhausted. Whereas the sample itself can get exhausted once somebody has used it for some sequencing or for some proteomics. So 2 diagnostics have already been developed and launched using our biobank. One was done internally. It's called MyPlatelet, which is to personalize the use of blood thinning medicines for cardiac stent patients. The other one is called CanAssist Breast. That is to personalize the treatment for early stage breast cancer patients, to tell them who are low risk, who need not take chemotherapy at all. So this is a huge benefit to the patients because they can avoid chemotherapy, which has a lot of side effects, causes a lot of trauma, is expensive, and also causes a lot of inconvenience to patients to go to the hospital. Overall, our focus is on cancer diagnostics. So they can be either non-invasive diagnostics. So if something today is done by biopsy or by surgery, can we replace that by a urine or a blood test? Second focus is to see early detection. So many cancers like lung cancer, gastric cancer, liver cancer, they are usually detected very late. And by the time they are detected, the disease is either advanced so much or has spread so much that even if you have drugs, they can add only a few years to a patient's life. Whereas the same disease, if it was detected several years before. The patient could have been treated by just surgery. The cancer could have been removed, and the patient would have survived for decades. So how can we build systems or diagnostics that can detect disease earlier in a cheaper manner? Because we know most Indians will not go for health checkups and cannot afford very expensive radiology and so on. The third kind of diagnostic is when somebody undergoes treatment. Some percentage of people do not benefit from that treatment or benefit for a short period of time but still have recurrence of disease. So how can we monitor and discriminate between patients who responded well to a treatment versus those who did not respond and either will need a change of treatment or some different modality altogether as early as possible, again before the disease has gone too far. So if any of you are working in these areas of low invasive or no invasive diagnostics, point of care diagnostics, early detection, and treatment monitoring, please feel free to contact us. We have many clients. We've been operational for 8 years now. Many Indian companies and many global companies, you will see the names here. Now I'm moving into giving you a few examples because, as I said, you may not have heard of a biobank before. So this is an example from just colon as an organ, right? So these are samples from one of our sites for a few years, 2-3 years only. And you can see these are all colon samples. So these are from Crohn's disease, inflammation, inflammatory bowel disease. These are cancer, colon cancer. A small percentage are normal because sometimes doctors suspect something is abnormal and will send it for testing and they turn out to be normal. So many of you, if you need normal tissue as comparison, again, a biobank will have access to some normal tissues also. So these 108 cases are normal. Polyps, which are sometimes the earliest stage. Some of these patients who have polyps may progress to have cancer later. Similarly, precancerous, which is listed. So you can see all different stages of some inflammation or disease in colon. Now, if we were to break up just the 762 cases that are colon cancer on the right-hand side, again, you can see all the different grades of cancer, starting from, these are adenocarcinomas, which is one category, grade 1, grade 2, and grade 3. So for each disease, we will have a spectrum of samples, from the normal to the earliest stage, to the middle stage, to the latest stage. So depending on the hypothesis and the question you are trying to answer, we will probably have the right kind of sample to validate whether your thinking is correct or not. This is another example how we work with companies. So this is a company out of Boston in US. So they are working specifically on a diagnostic, immunohistochemistry based diagnostic that can predict at the time of surgery which patient will respond to a drug which is called irinotecan. And there's a set of drugs like that. These are called topoisomerase inhibitors. So they were looking for colon cancer patient samples who have been treated with irinotecan and who went on to either respond or not respond. They wanted both to validate whether the marker can accurately segregate between those that are going to respond and those that are not going to respond. So these are samples that were provided to them by us because we have colon cancer samples as I showed you before. And we also have data to know which patients are treated with what disease and whether they had recurrence or not. So if you see these 4 panels, these are 4 different cancer patient samples. On the left-hand side are 2 cases which both stain very intensely with the marker that predictors has developed. It's an antibody predictors has developed. They say that these patients do not respond to irinotecan. And we know that these were non-responders. On the right-hand side are 2 samples that did not stain and are known to be, by they had hypothesized and they had proven before that the marker shows that those samples that do not take up the stain come from patients that do respond. So using our samples, they are validating the accuracy of their marker. And they have samples from many other parts of the world as well. So we work with clients or collaborators to provide such annotated samples and data. Now I move to another example, which is breast cancer. Many of you in the audience are working on cancers and are looking for data, which I will exemplify here. So over the last 7 years, we have been collating breast cancer patient samples from 9 of our partner hospitals. As of now, we have 16,670 some cases, which is the largest database of breast cancer patient samples in India. And the level of data that we have is shown here. So we have patient demographics, ID, UHID, which we don't share, gender, age, nationality, and in many cases, family history. We know how they were diagnosed, whether it was biopsy or some kind of radiology, etc. We know their surgery details, whether it was a mastectomy or breast conservation surgery, etc. With full details about the margins, the size of the tumor, lymph node involvement, etc. We know what kind of chemotherapy was given, if it was given, when did it start, when did it end. Not everything is always complete, but we have quite a bit of data on this. And if they did not respond to the therapy, whether a second or a third line therapy was given, how many cycles were given. And for many companies that want to know whether their drug is being given or not, we also know the drug name and the combinations. So this is called real world data. What is the real world usage of people's drugs? We have. Since it's breast cancer, hormonotherapy is also given. There are also certain targeted therapies. We have those details as well. Whenever radiotherapy is used, that. And most importantly, we continue to track patients for many years. So we know whether they responded to the drug, whether they had recurrence. So we typically have data for 3 to 5 years. And again, if they have recurrence, we have details of where the recurrence happened and how it was treated. So this becomes extremely useful to mine for epidemiology, for effectiveness of diagnostics. So if you see a long gap between how they were first, some suspicion came to when it was definitively established that they have breast cancer, which diagnostics are most effective, both cost and treatment-wise. What is the frequency of different subtypes of breast cancer? What are the treatment paradigms being used in various hospitals that we are collecting? Is there a difference between hospitals, etc.? So, showing you some data on where we have matched blocks. So, total number of cases, as I mentioned, is 16,670 cases. But blocks for 4,600 cases are usable, in the sense that hospitals are required to keep samples for 5 years for patients to come back and use them for any second opinion or any other purpose. So we can only use blocks that are pre-2016. 50 is now allowed because 5 years have elapsed and so on. So as of now, this 4,600 cases were where blocks were available up to 2014. And as every year passes, more blocks will become available for RNA. Out of these, 80 cases are of biopsy alone, and the remaining are where resection blocks are available. We have 100 cases of matched biopsy followed by resection. We also have a few cases where we have the primary tumor and also surgery that was done for metastasized tumor. So many times people are looking to see what is the signature between primary versus metastasis and what are the genes proteins that changed when it was metastasized. We have full treatment and 3-year outcomes data for approximately 1,200 cases and 5-year treatment and outcomes data for 583. All these numbers have gone up a little bit since this slide was made some time ago. We provide samples in many different formats. We rarely give out the entire block, but we give out unstained sections for people to try certain markers, for curves for doing DNA, RNA work, etc. And we have access to digital scanner so that high-resolution images can be taken of these slides and can be used for digital pathology. So there are many ways of separating different types of breast cancer. There are certain receptors that are expressed on breast cancer which are called estrogen receptor or ER, progesterone receptor or PR, and HER2 receptor. So these, depending on their presence or absence, determine the course of treatment of the patient along with the stage of the disease, etc. So of the cases that I mentioned before, how many cases fall under different combinations and permutations of this PR, and HER2 are shown here. Most people in pharma currently are trying to work on triple-negative breast cancer because this is a very aggressive form of the disease and there are no targeted therapies available. So we know we have a very large number of such cases, and continuously every month, every year, the number of such cases goes up since we are pulling in cases and data from many more sites, many more years. This is the stage distribution. So sometimes we work on stage-specific cancer. So stage 0, which is basically the cancer is extremely tiny, completely in the in situ. Early stage, still early stage, 2A is considered early stage. From 3A, 3B, 3C, and 4, these are considered late stage. So since we work with Apollo Hospital a lot, we see that most of our patients, majority of our patients, fall into the early stages. But if we were to compare our data with Tata Memorial or PGI or CNC Vellore, etc., we see that more patients come at late stages to these public hospitals compared to private hospitals. This slide is to show the treatment and outcome data, which I mentioned before also. So we have 1,000+ cases for which data is less than 3 years longitudinally. There are 1,500 cases, 1,490 cases for which we have full treatment and more than 3 years data on how their disease progressed. We have another 773 cases for which we have treatment and more than 5 years data, and then 27 cases for which we have more than 10 years data. So for developing predictive algorithms, can your marker, can your protein, can your signature predict outcome 5 years later? This is how this data and sample becomes very, very valuable. So I showed you a lot of work that we have done in breast cancer, and similarly, we are now building such data sets over the last 3 years for other major cancers that are prevalent in India. So for lung cancer, we have a database of about 5,000 cases, colorectal, head and neck, gliomas, which are brain cancers, kidney and renal cancers, ovarian cancers. The numbers are lower than breast cancer, but slowly the depth of data and matched blocks and samples is being built. So we are open to collaborations with academia and industry to use this data set to build healthcare solutions. As I mentioned, we are creating a library of digitally scanned images that could be used by many groups for analyzing different questions on why certain tumors progress, why certain drugs don't work, and so on. Even classification of tumors is changing based on deeper data sets that are being accumulated across the world. So the reason we are doing some of this work is that we feel there is a tremendous scope in India to optimize cancer treatment. Cancer is mostly a disease that is environmental. Very few patients have cancer due to hereditary risk. And so as life expectancy is going up in India, we see more cancer. So life expectancy when we got independence was only 32 years. Can you believe it? And that is also for males, because people have not even really documented for females. So probably it was even lower for women. And in 2015, when it was last published, it was 68 years. So 32 versus 68. Cancer is a disease of the middle age. So if average age was only 32, obviously we would not have come across many patients who have cancer 60 years ago. But this is a sign that we are living longer, and hence we are seeing cancer come up usually in the late 50s, 60s, 70s. In fact, more than 80% breast cancer cases are seen above the age of 40. Median age for Apollo patients is around 55. So as long as we can catch the disease very early, we should have very good cure rate, not just treatment. I'm using the word cure deliberately. If you have stage 1 or 2 breast cancer patients, the 5-year survival is more than 90%. As we get to stage 3, remember I showed you stage 3 later stage, the 5-year survival drops to 72%. And as we get to the latest stage, stage 4, by which time normally it has spread to many parts, that drops drastically to 22%. In the last 40 years alone, in United Kingdom, the survival rate for breast cancer has doubled from 40% to 78%. So if that can be done with earlier detection, with better counseling, with more effective treatment that is monitored, with better surgery and treatment paradigms that people can afford, we should be able to set a target for something like this for India as well. Can we decrease the mortality due to breast cancer or any cancer that we pick that we believe we can work on in the next 30-40 years by half? And the reason I use breast cancer as an example a lot is because 45% or half of Indian breast cancer cases are seen between the ages of 30 to 50. So if we can cure them or really give them effective treatment, one would add decades to a person's life, not just 6 months or 1 year or 2 years. And this is at a peak productive age. A person of 40, 50, you can expect them to be active for another 20, 50 years. Very significant change in quality and quantity of life. So diagnostics you could be working on could be gene, could be protein, could be metabolites, could be images. And for any of these kinds of healthcare solutions, we would have samples on the left side, different kinds of samples, and various techniques on the right side, any of which you may be interested in. I'm going to talk briefly about some other work that we do relating to patient samples, how we use them internally to offer services to pharma companies. So we collect live cancer tissue from pathology and operation theaters. And I'll give example again of breast and glioma. So this live tissue is processed in a sterile manner in our lab. And we propagate the cancer cells in our lab. And then we do multiple different functional assays using these cells in the presence of new drugs. So for example, here is a tumor tissue. We will dissociate the tumor tissue. We will derive cells, and the cells in 3 dimensions look like small organelles, like balls, spheres. And then we use them with and without drugs to see whether there is an inhibition of proliferation, decrease in stem cells, decrease in markers that are expressed on their surface, etc. So people who are developing new drugs like pharma can know whether their drug will be effective actually in patient use. So these are many different brain cancers that we have worked with. And these are what are called dose response curves for breast cancer. So here we are using different drugs. This is a compound, these are client compounds, so we just call them some name like that. So this is somebody's drug that they wanted to test. And we tested to see that the drug actually inhibits cell growth. So without the drug, the cells are growing at 100%. In the presence of the drug, at high micromolar, 10 micromolar, the cells stop growing. This is another compound or another drug, in which case we saw that the drug works very well in 3-dimensional spheroid cultures, but not in monolayers. And we also run standard of care therapies that are approved for patient use as comparators. So people can see whether their drug worked equally or better or worse compared to drugs that are already available in the clinic. So this is services that we offer to our pharma clients, biosimilars, pharma, nanoformulation companies, herbal companies, nutraceutical companies, etc. This is another application of our biobank where we have access to skin samples, completely normal, healthy skin that is one of the waste material from cosmetic surgeries or elective surgeries for grafts and so on. So in this case, cosmeceutical, nanoformulation, and many types of companies come to us to test their drugs, their dermal formulations, toxicity on human skin, healthy human skin. So we apply those drugs or those ointments or those formulations or irritants or herbals on the surface of skin, which is normal healthy skin, and then we incubate it for various periods of time as required for the assay. And then we can tell whether the compound or the drug or the formulation we tested penetrated the skin or not, whether it caused corrosion of the skin, whether it caused toxicity that was released, many different ways that we do these assays. So this decreases the use of animals and also decreases the toxicity that may be experienced by patients later on. We do it by multiple different types of staining. It could be immunohistochemistry, as shown on the top left. It can be immunofluorescence, depending on the markers and the localization. Coming towards the end, this is our team. We have a lot of women who work with us. We are very proud of our team that has really made us come this far. And the team that you see is a small team compared to many people that we rely on across our partner network of hospitals. A lot of our patients we thank, of course, whose samples we have, doctors, pathologists, IT and medical records teams, ethics committee members. We have a very large network of colleagues that we work with. So bottom line is we have access to high quality, ethically obtained, well annotated samples and deep databases. This is typically a bottleneck that is cited by many companies. We would be keen to work together to address this gap. Thank you very much. I can take questions. Please feel free to write to any of these emails, research@sapienbio.com or queries@sapienbio.com if you have any requirement or interest in working with us. Thank you. Happy to take any questions.
Jyothi, are you there?
Yes, ma'am, I'm here. Can you please stop sharing the virtual memento for Rashmi sir? I would like to ask a question.
Sure.
How can this is surely an interesting topic and something new that we haven't heard before. So how can we students or early stage researchers get an access and use latest applications like machine learning, artificial intelligence to do something about it?
It's a very good question.
Yeah.
It's a very good question, Sadia. I think I forgot to mention, before COVID came, we used to take interns quite regularly. I think we've had about 150 plus interns in the last 7 years.
Okay.
So there are two things I would say. One, we ourselves are currently not experts in AI or ML. So typically we partner with companies that have this expertise. So we provide patient samples, patient data, and many biological applications, access to doctors and hospital networks. But then the companies or the groups we work with come with either genomics technology or with AI or digital pathology and so on. So part of it is you need to decide which side do you wish to be on. If you want to be in AI and ML, perhaps you wish to be with a company or a group like University of Hyderabad or others that already has that expertise, and then approach us through them to say, I already know or I have this application, and now I would like access to this data or these samples for proving my hypothesis. So one is that you need to decide which area you wish to work. The second is that we do not receive government funds and we have no other support in terms of funding. So normally we have access charges for these samples because these have been built in private mode. So the other thing that I suggest is writing grants where you allow for some funds where access to samples, data, and even ethical approval to share this with you, we have to pay EC IRB fees. So that we can discuss depending on the topic that you have in mind, that there should be a little budget that you allocate which can help us offset our costs for working with you. So the third thing I want to mention is many times people come to us who are from pharma background or from technology background, biotechnology, and they work with us for 6 months on data projects. Because normally in universities, you may not be exposed to what are real life patients getting treated with. How are they getting diagnosed? How are they getting treated? What does data look like? Is it complete? Is it not? So many people have worked with us and we assign special topics and we help them create a data set of, let's say, 100 cases. And that they become very good at then to understand if you are interested in colon cancer, for example, how does colon cancer get diagnosed and treated in India? So it will give you real information on how certain patients' subsets are diagnosed and treated, what are the outcomes, what are drugs used, etc. So those are the kinds of partnerships we can enter into.
Okay, ma'am. Thank you so much. I think that answers my question. So if somebody else has questions. Right. So the question is, are you planning to take any interns any sooner?
This COVID is a very difficult time. I cannot say yes or no, but my suggestion is to please write to us because depending on the kind of project, so we are not taking interns in the lab right now for obvious reasons. It's very difficult to operate in the labs right now. And also we do not take interns for less than 6 months because it takes us a lot of time to explain to people how to work with patient samples, patient data, because there are a lot of ethical and safety issues. So if you are interested and you have a minimum time period of 6 months that you can devote, then I suggest you write to us either at queries@sapienbio.com and say which is the nature of your work and which area would you like to do internship. And then depending on if it's possible, if it can be done sitting at home or it can be done in a way that minimizes your exposure in a safe manner, we will consider it. And we will take it up once the COVID has been destroyed.
Right, ma'am. Okay, thank you. So that is all we have for question session. And this is a virtual memento, ma'am, that we want to present to you.
Thank you. This is good. This is better because it will not anyway be in the office. Nobody is in the office these days, so virtual is good.
Yes, ma'am. So thank you for the very insightful session, ma'am. Though I'm sure this is a very new topic for most of us, your talk was very clear, concise, and understandable. We wish you luck for the mild platelet and can assist diagnostics. And I'm sure the audience here has learned a lot today from your talk and would like to further explore about it. The significance of machine learning and AI in the field of biobanks and its research was also seen through your talk. And also we wish Sapien Biosciences and Solemn Sciences a very good luck for the current and future research.
Thank you very much, Savia.
Thank you very much for your... Yes, ma'am, please go ahead.
Thank you, ma'am, for your wonderful session. Already Sadia mentioned about internship. We are also working on some biomedical applications in collaboration with Apollo, ma'am.
Okay.
R&D. We are taking cough samples from pneumonia TB patients, ma'am. Actually, we have started the project from 2013 onwards. So initially, that is a DHC funded project. Now, BIRAC is supporting us, ma'am.
Okay, very good.
For validating our whatever we have done, we have collaborated with Apollo Hyderabad, ma'am.
Very good. Happy to hear that.
Okay, ma'am. So if you guide us so that we can take up a few projects which will be useful for the society. Mainly we are focusing on society.
Yes, so our expertise, Dr. Padma, is much more in cancer.
Okay.
So if your faculty or in your students, there is interest in early detection of cancer or non-invasive detection of cancer or something like that, we can talk more and see where there is mutual interest.
Okay, ma'am. One of our faculty is working on breast cancer, ma'am.
Okay.
So We will meet once, ma'am, and discuss whether he is doing good thing or whether you can suggest, ma'am.
Sure, sure. We can do a virtual meeting because as these days we are doing one meeting.
Yeah.
Actually, very easy.
Yes, ma'am. So, even though a pandemic is troubling us, but we are able to capture resources from the entire globe. That is the advantage by using digital technology. So, we are able to call all eminent speakers. So, we are able to motivate all our students as well. Even for faculty also, it's very good learning. If we know something, then only we can teach to children. So,
yes, it's a very good initiative. I think human beings are good in overcoming challenges. We have a lot of flexibility and resilience, and this is a very good example of that. How you are doing a 4-day meeting, all virtual.
Yes, ma'am. Actually, initially we have postponed thrice, ma'am. Why? Because we want to invite all of you to our campus, but we are unable to do that one. We wish COVID will go quickly. I want to see your presence at our institute, ma'am, so that many students as well as faculty will get inspired by listening to your words. I know I have opportunity to listen to your voice. One of the session organized by Vamsi Krishna.
Yes. Yes.
Now this is the second time I am listening to you, ma'am. It's really that is very much needed. Now many people are suffering with heart attack, cancer in our country, and diabetic also. So as an engineer, as a doctor, collaboratively we have to do something which is possible to detect early. So we can do collaboratively something, ma'am. So I wish so you will visit our institute, and so that it will be useful for both of us, ma'am.
In fact, biologists have relied routinely on engineers, physicists, all the equipment that biologists use, whether it is sequencing, whether it is microscopy, whether it is LCM, all of these have come from non-biologists generally. So we really appreciate, I personally know how much help biology has gotten from other people, and particularly engineering, because so many of beautiful instruments that we have would not have come unless engineers and physicists and many other disciplines had come to biology, making it better. So very much needed.
Thank you, ma'am. Thank you
Thank
for
you.
your wonderful session.
Thank you. In fact, I'm going to stay on and listen to the next few speakers, because today you have quite a few speakers in healthcare that are of interest for us as well.
Okay, ma'am. Thank you, ma'am.
Thank you.
Thank you, ma'am. I request Pratisha to introduce our next speaker for today. I hope you enjoy the session, ma'am.
Thank you.
Good afternoon, everyone. Our next session is on the topic AI for Oncology. It is my privilege to introduce Mr. Dinesh Koka. He has done his bachelor's in ECE from Sri Venkateswara College of Engineering and his PGDM from IIM Lucknow. He has spent 14 years of his career with Wipro GE Healthcare and became the director during 2013. In 2015, he became the COO of EkinCare, which is an AI-powered integrated health benefits platform helping organizations and employees with a preventive, predictive, and highly personalized healthcare solution. He is the co-founder and CEO of Onward Assist, which is an advanced cancer prognostics platform helping oncologists take better treatment decisions and hence improve outcomes. We are very delighted to have you here, sir. Now, without any further delay, let's get into the session. Over to you, sir.
Okay. There's a technical issue that sir is facing. He'll be joining us in 2 more minutes.
Hello, sir. Dinesh, sir.
Yes, madam.
Welcome, sir.
Yeah. Hi. Can I start? Hello, ma'am.
Pratyusha,
Yes,
can you introduce sir once again?
yes, ma'am.
Jagnu ma'am, can you please switch on your video once? Sadhya and Pratyusha also, please switch on your video. Pratyusha, please. Okay, but please introduce sir.
Welcome back, everyone. everyone. Our next session is on the topic AI for Oncology. It is my privilege to introduce Mr. Dinesh Koka. He has done his bachelor's in ECE from Sri Venkateswara College of Engineering and his PGDM from IIM Lucknow. He has spent 14 years of his career with Wipro GE Healthcare and became the director was during 2013. In 2015, he became the COO of EkinCare, which is an AI-powered integrated health benefits platform helping organizations and employees with a preventive, predictive, and highly personalized healthcare solution. He is the co-founder and CEO of Onward Assist, which is an advanced cancer prognostics platform helping oncologists take better treatment decisions and hence improve outcomes. We are very delighted to have you here, sir. Now, without any further delay, let's get into the session. Over to you, sir.
Sure, thanks. Thank you for the introduction. Hello, everyone on the call. Hello, Jignu, how are you doing? So good to see you here. So thank you for the opportunity. Great to be here, obviously, at a prestigious, conference like this. Would be great to, get to interact eventually, right? The topic given was pretty broad brushed. I took the liberty of kind of trying to cover a few topics of interest, AI in especially in the oncology related applications. So I know we have a kind of a 90-minute slot here. My goal was to use the first half for sharing, from our experiences, what we do at Onward Assist, both what we do per se, our work, but more importantly, how do we see that space, right? What are the opportunities from application of artificial intelligence? So I think, to the benefit of the audience, we are a startup, right? We are based out of Hyderabad. We're based in Gachibowli, right? Obviously, as a startup, you typically are focused on a niche because you want to pick a problem that you want to solve rather than go really broad. But I think for the benefit of the folks in the audience or who would be watching this session, I thought from what would be beneficial, I think I could relate from the research that we did, right, when we got into this space. So, and give at least some level of introduction into the space about the challenges in the space and where all AI can play a role, so that the hope is it can trigger some more ideas, right, for folks to look at applications of data science, machine learning, analytics, or computer vision or whatnot in the cancer care space, because like all of us would know, it is a tough disease, right? It is a tough biology, right? A tough disease to solve, and the way the disease is treated continues to evolve, right? Continues to progress, continues to make incremental progress year on year, but there are still a lot of unresolved challenges there, right? Which is originally what motivated us, inspired us to look at the space even, right? So I'm going to share my deck here, and then I'm going to use this to kind of help me, present my thoughts, right? So, like I said, so out of the 90 minutes, the goal is for me to kind of present our work for about 45 minutes, but then really open up for Q&A, right? Does that structure work?
Yes, sir.
Okay, great, thanks. So good. So like I said, so we are, the introduction already did its job, right? We are primarily a cancer analytics platform, and we are a cancer prognostics platform, right? So the goal being to, help clinicians or decision makers who are taking decisions every day, right? Around, around multiple areas, right? Be it diagnostics, right? In cancer, the diagnostics is primarily around pathology, right? or in radiology, right? For example, if the patient, for example, lung cancer, right? The patient, what typically happens is the patient either gets screened asymptomatically, right, or reports a symptom, right, some discomfort in the lung or whatever, and then they're asked to go get a chest X-ray or a CT, right? That's looked at by a radiologist, and they say, it's clear, right? They clear it and say that there's no problem, or they say, something looks suspicious, go get a biopsy done, right? So biopsy is where you actually put a needle to the site and take a piece of tissue and then put it on a glass slide, see it through a microscope report, right? The pathologist would then confirm, right, what it is, and then the oncologist would see all of this and say, I want to see some more kind of slightly more stratification of this patient, right? So they may ask for following molecular studies, right? Molecular pathology or ISCs of even, and definitely genomics, right? Genomics is definitely more and more being used even in a country like India to basically be able to stratify the patient down to a small population. Then they would look at all that data, right, and then try to choose a line of treatment, specific line of treatment, right? They choose the line of treatment based on which is going to give me the best chance of success, right? So that is the way the decision is taken, rather than they go in, they're not going in thinking, okay, I know this is going to work, right? And this is exactly the result, and the patient is going to be completely cured of the disease, right? That's not how it happens in cancer. I mean, it happens in other diseases, right? So cardiac or orthopedics or any of the other disease areas are, but in cancer it's more about which line of therapy is going to give me the highest likelihood of giving a good outcome, right? So that is how I'm going to take a decision. So we try to our capabilities in machine learning, computer vision, right? So we try to look at which are the areas that we can solve, and then we try to use our capability to process, right, patient data, and then give computational tools which can be useful for these individual clinicians, right? So that's why we say we're advanced healthcare analytics platform. But what eventually we do is we use the underlying technology being machine learning and computer vision. We use that to primarily build automated diagnostic tools as well as treatment decision support. When we are talking about oncologists being able to look at huge amounts of data and then taking that decision, right? So that's primarily what we are. A small introduction about our own work, right? So my introduction was there. I've worked in the healthcare space. My co-founder, he is the CTO. He has a PhD in this in the computational area, and then has worked with large enterprises in this space and holds a chunk of patents, right? So that is Vikas. And then we also have a chief medical officer who brings close to about 30 years of experience in the field of in the diagnosis area, in the lab space. So that is the team, and we have a fairly strong team of based out of Hyderabad. And then very early, while we had the capability in AI, right, we clearly realized we don't know everything about the disease, right? So while we worked in the healthcare space, we've interacted with doctors, right? We are not oncologists ourselves, right? So we went out, we sought, linking with advisors, right, to get the right amount of clinical input as well. So if you want to, whatever be the venture that you might want to build out in healthcare, it can be in cancer, it need not be in cancer, right? But a key thing is for us to have a clinical mentor, so to say, right at very early days, right? Because that's going to make a big difference in terms of the progress that you can make with a venture, right? So, so there are startups that I advise. There are also, research teams, right? Research teams are at fairly big institutions, right? Academic institutions, right? So, which have great capability in the technology front, right? Where we also work and mentor, one of the first things that we try to get them on their teams is a clinical advisor, right? So someone who can bring clinical insights, right? Because that makes a big difference as to, one, are we building something of value, and two, are we building it in the right direction, right? So those are two things that we saw very early, right? So that's about us, right? So enough about what we do. I'll get down to more about the problem that we look at and the opportunities, right? Again, the opportunities that the way we saw it, and the opportunities that any of you, right? So I'm thinking the audience would be researchers, other computational engineers, people with an interest, would be other startups as well. So that's the way I kind of structured the presentation. So my talk is more around focused on our problem area, which is cancer analytics, right? So that's the full disclosure that I'm giving, that's the focus area with which we are approaching this, right? One was couple of problems, right, in the way when we are treating cancer. One is of early diagnosis and prognosis of a cancer type. That being able to catch the cancer, right, earliest, right? So I'm sure you would have heard cancer also progresses in stages, right? There's 1, 2, 3, 4, and there are sub stages within that as well, right? There is the way that it is staged called TNM, right? Tumor, node, and met, right? So based on that, you actually measure how far it has progressed. The reason you want to know that is it determines, what are the treatment options at different stages. One, and also it also actually determines whether you're going to take an aggressive or a passive or a conservative line of treatment to a patient, right? So there are a lot of factors which go into taking a decision in that sense, right? So early diagnosis, prognosis is critical in that sense because it clearly facilitates or helps deciding the subsequent clinical management of the patients, right? And with higher accuracy or higher chances of better outcome, right? So being able to catch them, right, early is very important, one, and also accurately, right? Even after staging, the same type of cancer could have multiple subtypes, right, variants, and each of those variants would have certain types of treatment options available, right? And then treatment therapy protocols, right? And we want to start based on whether the tumor is inaccessible, resectable. I mean, we start with surgery or may not start with surgery, right? And we start with chemo or radiation, and then we move on to hormonal therapy or chemo, right? So it's always an iterative treatment cycle for cancer. And again, the thought here is to make it relevant from a data science perspective, right? What are the problems from a data science that the way we can approach, right? Providing a solution to an oncologist, right? So early diagnosis, prognosis is clearly, so again, here you're either trying to look at patient data, and then this is done by a pathologist or a radiologist, or sometimes just the physician, right? The physician looking at the symptoms of the patient, and then the physician actually makes the decision on what to actually go get that chest X-ray, right? And then on to the other things, right? Being able to read those symptoms right, and then getting them into that into that workflow of diagnosis and prognosis and treatment, right? So a lot of the times, I mean, the challenge primarily is being able to kind of identify the challenge much earlier, right? Hopefully in stage 1, it's not stage 2, right? When we talk about in the later stages, right? So 3B, 3C, or 4, we are really talking about limited options in terms of the patient, the way it can be treated. So obviously there is a lot of data, right? So this involves looking at data and then making that decision or doing that screening. So there are huge opportunities here. And the second thing is, once it's been caught and then you come down to looking at all of the patient data, right? And then there's a bunch of data, right? Where it's confirmed as cancer, right? You've done different types of analysis. You've got maybe your radiology. You've got your pathology, genomics, and whatnot, right? Different types of prognostic tests that you've done. You have all that data. The way cancer treatment decisions typically made is in the form of what they call tumor board, right? So there's a board of specialists sitting around and then making that decision on how to treat a patient, right? Meaning, you typically have your surgeon, your surgical oncologist, radiation oncologist, medical oncologist, your diagnostics, all of them together, right? Sometimes even the plastic surgeon, right? And then looking at the patient, patient information or the patient file, and then actually taking the accurate decision, right? So it is a problem of looking at a lot of the data and then choosing the right decision, right? So I would typically put it as it is important for the oncologist to classify these patients into high or low risk groups, right? And today they use a lot of statistical tools already, right? Actually, you'd be surprised, by certain cancer hospitals setups already having a proper statistical team, right? Statistician team, right? So their use of things like SPSS, right? So Excel, at least Excel in terms of looking at data and then doing some kind of an analytics, right? Because they're always looking at how has a similar patient responded in the past, and can I learn, can I glean data from all of that experience, right? So that is how you make progress in this. Again, it's an opportunity, right? Clearly, this is a case where you have someone looking at data, right, and in different forms, right, multivariate forms, right? These could be numbers, these could be text, category, labels, and images, right? And then actually saying that what, I have these options, right? Based on this data, I think I'll choose this particular line, which is what is done today, right? I choose a line of treatment, go through the entire, almost the entire protocol, keep checking intermediate. If it doesn't work, right? Unfortunately, it doesn't in a lot of cases. The case goes back to the top of the decision tree, right? Where again I look at all of this information and then to try to choose a line of treatment, right? So that's what happens, right? Again, if you have to paint it like a data science problem, it's about collective wisdom, right? It's about all my academic learning, my collective wisdom, looking at all of that data and then making that treatment, right? So again, an opportunity to see if this can be solved by assisting the doctor in looking at all of this data and giving some other recommendations that can be made with the objective of increasing the probability of the actual treatment decision succeeding. Right? So that's the end objective, right? Eventual objective, right? Yeah. And the reason is why are we harping on this is none of this might be new to you, right? 50% or sometimes even less, 50% of all patients, right, receive treatments which don't work for them, right? In some cancers, it is even lesser, right? And then it's not a problem that is unique to one country or the other. This is a problem that is across, right? For a country like India, we had about 1.5 million cases every year, incremental, right? That is the disease burden, right, that we had every year. So now that's the importance of those number of patients need clinicians need to be taking accurate enough decisions on so many cases, right? So that is the challenge we're talking about, right? And how does some of this I spoke about earlier, right? How does an oncologist actually decide on a treatment, right? It's about, again, we're basically looking at different types of information, right? Multiple types of data, right? A lot of a lot of clinical history, right? Lifestyle data, primarily out of patient conversations, but obviously a lot of the patient history if it's available, right? The value of clinical history is enough said. And then comes the input from the diagnostic processes, right? Like I said, be it the radiologist or the histopathologist, right, who are doing the diagnosis, and then associated diagnostic tests that are done along with them as well, right? In addition to all of this, the oncologist would definitely be referring to academic material, right? Going back, referring to academic material, recent publications. This is because this is one area of science where you constantly have incremental knowledge being added to the vast vast repository already, right? There could be new biomarkers, meaning a new presence or absence of a certain feature, right, or a cell or a cell feature which indicates a certain prognosis, right? Meaning indicates how a certain type of cancer disease will behave. Right? So cancer is not one disease, right? It's a collection of many, and then you have different types of cancer diseases based on the site, based on the origin, right? Based on obviously the progression as well. Right? So that is this is the kind of workflow in which they're actually taking a decision. So if you look at this again, this is basically data being taken in by the doctor, through multiple of these channels, right? And being able to make sense of all of that, and then trying to match this with my wisdom of having treated 1,000 patients, right? And the kind of results or outcomes that I have seen, and then being able to choose or being able to make a decision on, okay, can I choose this particular line of treatment for a patient, and then accordingly hope for the best outcome, right? But some of this may be obvious, right? It obviously has limitations, right? If I'm a doctor, I have 20 years of experience, right? Even if I'm treating something like 500,000 patients every year, right? I have maybe the wisdom of 10-15,000 patients, right? Spread over a fairly good experience timeline, right? But like I said, that's 20,000 or even 30,000 compared to 1.5 million new patients being added every year, right? In different types even. Plus the advances, right? The new advances, newer biomarkers, newer discoveries being made on how the cancers are behaving, right? What are the genetic predispositions, newer type of diagnostics, newer type of genomic test data which have prognostic value, right? Me being able to keep up with that. There is always constant reading, right? So you'll be surprised with the amount of learning and constant reading that a doctor does, right? But if you I'll continue to draw the analogy, right? If you look at it from a data standpoint, this is constantly taking in new type of data and learning from all of that, right? Limitations is also around multimodal data, right? So you're mixing and matching multiple types, right? You have your reports coming in from different types of diagnostics. We are trying to match with newer publications, right? So that is the second piece. And then the third is, even suppose I'm a hospital, right? I have a setup in one city, right? I also have a setup in a neighboring city, in a tier 2, tier 3, where we already treat patients locally, and maybe another 2 or 3 more as well. So I have 3 or 4 setups, right? There is no way, if I'm a doctor treating at one place, town A, there is no easy way of collecting the learnings, right, from this town 2, town 3, town 4, right? So there is no one way of creating a knowledge base, because we are not built like computers, right? So that is definitely something, right? So which is the reason why I keep reading papers, reading publications, I attend tumor boards and talk to other clinicians as well, right? So if if that are, if these can be viewed as opportunities, where can we build solutions to help, this clinician, right, or the treating oncologist. So, those are avenues where, structuring data right, figuring out solutions to process them right, and draw out patterns or trends, right. Those are areas which obviously helps, right. So I did see a question. I think, like I said, maybe I'll stop in about another 15-20 minutes, and then I'll be happy to take the question at the end of the session if that is okay. Unless if that doesn't work, do let me know. The other thing is, one was the complexity, right? Different types of data, right? Second is also there's this amount of data, right, that keeps growing, right, year on year, right? Number of cases obviously is growing, right? That's growing at about between 24 to 25% year on year, right? The number of tests that are being done. Two, also there's newer discoveries, right? Newer type of biomarkers. There is newer understanding, right? Year on year, right? So obviously that also adds one level of complexity, right? So combined with on one side we have different types of information that I need to process to be able to choose exactly one line of treatment, right, with the best outcome possible, with the best probability of good outcome. Second is the amount of data that we need to look at, right? So it's a reality of the healthcare industry, right? So the number of tests or number of cases keep growing year on year, whereas the number of specialists, right, number of doctors in that area may not necessarily be growing, right, in keeping pace with the number of cases, right? So there will always be that gap, that delta, right? So those are also places where hopefully there can be solutions that we can look at, right? So that's primarily been my objective as well, right? So if you look at all of this put together, right, if you have to kind of summarize what are some of the themes, right, that we have explored ourselves, as well as the other startups that we see, right, who are leveraging leveraging data science, leveraging AI to build solutions, right? So this is primarily these are just a few thoughts around that. One is intelligent diagnostics, being able to look at patient sample. It could be in various formats, looking at that and then kind of doing diagnosis, right? Presence or absence, or yes or no, right? Or staging a certain type of patient, right? Or doing prognosis, right? So that is one. Patient and provider data management, right? So I mentioned being able to process or enabling an oncologist to look at data in the right format, right? So there's different types of data that I mentioned even today, right? If you have a tumor board where you have all this, like I said, different types of clinicians, 99% of patient data is still in a file format, right? In 99% of the cases, right? So these are paper files carried by the patient or copy maintained by the hospital. Some of it may be digitized, right? Some of it may be available in digital format, but it definitely wouldn't be more than about 25-30%, right? So you can take that about 70-75% of that information that is being looked at by the tumor board is not necessarily in digital format; they are in paper format. So you can understand the challenges, right? They're not from a context standpoint, right? I would, as an oncologist, I would need to be looking at them, right? Something like someone writes NACT, right? Neoadjuvant chemo, right? And there's a report which is right somewhere in the middle of the file. You need an oncologist to get the context, right? Be able to appreciate that, and then be able to see the entire set of data, in the right context, right? And see the timeline, and then exactly understand where this patient is. So that is an opportunity where we've seen a lot of solutions, a lot of lot of companies and startups trying to solve, because being able to organize the data, right, in the right context. Because once that's the problem of structured data, right? I mean, the biggest problem in healthcare is, there's a lot of data per se, right? Not necessarily data that is usable, because, unless it is structured and it is in a usable format, no amount of algorithms or models that you build will be able to use any of that data, because if it's not in a structured format, right? So that's a great problem to be solved, right? So this was in fact one of the points that one of our partners very early actually said, if this could be solved, right? So we don't solve it today, right? But this is definitely of a lot of interest, right, for a lot of the hospitals, right? Because it solves a real problem. Next is drug discovery, right? I'm sure, especially given this situation, right? Especially given COVID, the role of machine learning in the drug discovery process, there's been a lot of realization, right? That the good that AI can do in the drug discovery process, it's always been used, right? But this is again one area where people continue to use, again, because of the sheer amount of data, right? Right from preclinical to clinical, as well as repurposing of drugs, right? Which is a big deal in cancer as well. So use of data science for in those areas. Again, these are what you would call matrix factorization, as simple as, and then being able to predict those, the right pairs, that has a lot of value, right? And we've seen applications of that in oncology as well, right? Home health, you have patients typically, especially in cancer, right? Treatment is long cycle, right? Patient gets treated over 6-9 months, right? And then there is always this intermediate, follow-ups, right? And typically, in cancer, invariably you would hear of patients, who miss their cycles, right? I mean, the original protocol was 8 cycles or 9 cycles or whatever, but they fell off the radar after 4 or 5 cycles, right? But the original plan was the target outcome would be achieved only if you complete the entire iteration. So those are things, right? But also intermediately being able to follow up what are the effects, right? What is the result on the patient's health based on all the stuff that is being done, right? So that is an area where there's a big role for analytics and data science as well. And devices and then robotics. So here is more of two different areas. Devices, we've seen even applications within an ICU or within a clinical setting, right, where you have, from an IoT standpoint, being able to centralize all the clinical data of a patient and then having a layer of analytics on top of that, right? So if you don't have a specialist, or suppose you don't have an intensivist, being able to track those real-time data, and then being able to kind of flag that to the nursing staff or the on-duty doctor, right? So those are real applications which are already being rolled out. Robotics is a place more around, at least we have seen examples in the patient engagement space, where you have, again, a patient who's under treatment, right? You want to know, for example, you want to understand, the pain thresholds of patients. You want to do patient engagement during the cycle of treatment, right? We've seen a lot of applications around robotics, especially around outside of India, where again there's they use NLP or AI to kind of engage, do the patient engagement, and being able to cycle that information back to the treating oncologist as well, right? So these are broadly the areas where we've seen good applications, and clearly one of value, right, from a clinical standpoint of value to the oncologist, and clearly applications of data science. Right? Applications of data science where you are able to collect data. Right? So for you to be able to build good AI, you need good data, right? And if at any point you are trying to build good solutions, you also need to solve for the pipeline, right? Solve for the pipeline of collecting data as well, right? Which is why when I talk about robotics or home health and wearables, right? These are examples where organizations or startups are trying to solve for the pipeline as well, right? So that you can collect meaningful, good quality data. Because only then can you do any kind of analytics or ML on top of it, and then give back insights to the clinician, right? And then on top of this, there is a lot more happening, right? So use of genomic information, especially, right, and in a variety of areas, diagnostics, prognosis, as well as in drug development, right, or target identification in a sense, right, where the ability to process huge amounts of data and different types of data, right? The ability of machine learning models to be able to do that in a consistent manner actually has led to a lot of teams, right? Research teams across the globe actually using this actively. If you take any of the big pharma teams, there is a computational team that they have actively, right, as part of their drug development pipeline or identification pipeline, right? And this is just one of those examples, right? So where you have for example, right, so you have some pathology, some blood-based tests, right, and then the patient clinical history, plus you're combining that with some genomics, right, genomics data, right? So there is an opportunity to do analytics on top of it, right? Use ML models to look at that different types, being able to see if you are able to kind of stratify one, right? Create discernible or identifiable populations, mutually exclusive populations, and then that becomes an input, right? That becomes an input for precision or personalized medicine, right? So each patient is unique, never truer than cancer, right? So that is where the opportunity is, right? So those are the opportunities, right? Now kind of coming to the challenges, right? So based on the opportunities are pretty exciting, right? Because clearly from the amount of value that you can provide to the clinician, right? If you are able to build those solutions, right? These are solutions which will be readily lapped up by a clinician as long as you are able to show the efficacy of what you've built, and you are able to demonstrate the safety of whatever you've built. I mean, it's actually going to be taken up, adopted by the doctors, right? Because clearly anything that is going to assist them in their process is readily encouraged, right? But the problem is there's quite a few challenges as well. So starting from difficulty in deployment, right? So AI is digital, right? So you're looking at digital data, you're looking at digital images are digital, the patient data is digital, right? So unless you have that existing digital infrastructure, no amount of powerful the most accurate AI, right, will help, because if you're not able to deploy, right? If you're not able to deploy in a usable fashion where the clinicians tomorrow can sit at the same desk, right, do the same job, but in essence use whatever you've built and help their job faster, they won't be able to do it unless it can actually get deployed, right? They're not going to want a computer on their desk, right, when the computer is of no use, right? The second is reluctance among doctors to adopt, right? So I did start with the kind of the disclaimer, right? Because healthcare is an area where doctors are taking decisions to on the lives of patients, right? So I'm treating a patient with a certain, because of my certainty of, okay, this treatment will work, this something else may not work, right? And then we're actually asking them to adopt something new where if they're not sure of the efficacy, right? Or it is going to add a new step, right? Or it is going to take more time. Earlier, I was able to, look at my patients, serve them, and give them a meaningful answer in a certain amount of time. Instead, using the solution, if I'm going to take 3 times of that time, it doesn't, it's taking my time away from my patients, right? So there's obviously reluctance, right? And there's a huge, healthcare is a hugely regulated area, right? So clearly, when the doctors are taking responsibility to take decisions, right, life-saving decisions on patients, obviously there's going to be a huge, gate of due diligence, right, before something, whatever you build, gets used by a doctor, right? There is ambiguity around regulatory guidelines for medical software, right? This is true of India, true of true globally as well, right? So these are, the good part is this is still evolving, right? And there is more and more clarity being, being given, and this is also being pushed by startups or innovative companies which are bringing innovative solutions, and clearly there is a clinical value that it can bring, right? So that is also where we see regulators also being open to these ideas and actually working actively, right, with companies to actually see, okay, how do we enable these innovative solutions to come to the market or be able to deploy in a clinical setting, but at the same time, how do we ensure, okay, they follow certain guidelines and they still ensure safety, right, the patient safety without compromising the patient safety, right? So those are things that are evolving. Lack of curated healthcare data, right? This will always be a challenge, right? Because here we are not talking about if you're looking at e-commerce transactions, right, trying to guess what this customer is going to buy. I mean, next tomorrow, right? It's still a tough problem, but it's definitely much easier than predicting. There have been 100 patients of oral cancer treated in this hospital, right? 20 different types, right? Given 5 different therapies, right? These are the outcomes. The 101st patient, right? So can I say confidently based on my experience of the 100 patients, right? And actually be able to predict the treatment, that's not so easy, right? One, for multiple reasons, right? The wisdom of those 100 patients, are they in structured format? Are they in a table format, which I can readily run a model on, right, and then predict for the 101st patients? No, right? If I want to build that, I may have to do a curation myself, right? So there are challenges around that. Like I said, so digitization is low, and because of which curated data, right, being available is always a challenge, right? Concerns about privacy and security. There will always be concerns about privacy and security. We live in a world where obviously the maturity around data security, patient confidentiality is much higher, and rightly so, right? So being able to build, especially a technology-based solution which needs to embed into a clinical setting. So these are concerns that you will need to keep in mind if someone is building, right? So that is definitely something that is there. The last one is lack of interoperability between AI solutions, right? Between just IT, so in healthcare, right? If you're familiar, just interoperability just within IT, between IT systems within healthcare, just IT systems, not AI systems, in itself is very difficult, right? I may have a laboratory information system, I may have a different patient health record system, or a different hospital information system. These 2 or 3 systems may not talk to each other, right? But as long as the patient is concerned, right, I walk into a hospital and walk out, right? I want my hospital or my doctor to know the complete information about me, right? The systems need to be interoperable, right, or need to interface with each other, right? That in itself is a challenge in the healthcare setting. I mean, even in the most advanced healthcare markets, right, interoperability is a big challenge. Then we're coming to interoperability between AI systems, right? In advanced, when you're building advanced AI models, some of the input data for your predictions may come from other, AI models, because you don't want to solve everything, right? Like I showed some of the streams within which you can build AI. You're not trying to solve all of it, right? You want to solve your niche, right? But the input data for that may be fed by another analytical tool, right? And if that the output from that analytical tool is not compatible with your system, then again any amount of advanced AI that you might build is going to be useful, right? So these are some real challenges, right? So the promise, like I said, the promise in healthcare is the value of the solution, if you can build the value of that, and because this is real, right? The impact that you can create in terms of the healthcare outcome, right? But at the same time, healthcare need to get a very good understanding about what are the challenges that doctors already face, right? And then how can you minimize the impedance, right, of whatever you build, right? However fancy or however good it may be, how can you reduce the impedance of adoption, right? Tomorrow someone is actually deployed it in a setup, right? Can it be used with the minimum of resistance or fuss, right? So that is always something that you always need to look at, right? Like I said, so this is a place which is pretty busy, right? There's a lot of folks coming at this from multiple angles, right? And this is an ever growing, right? Even this chart might be dated, right? Because there are obviously larger companies, right? Diversified companies who are healthcare companies who are kind of looking at the promise of AI and then trying to see how they can build value-added solutions for their clients. There are other large technology companies, right? Their strengths are in building these large tech platforms, and clearly healthcare is a huge domain, right? And then clearly they see can they make a difference, and they're trying to build solutions of that. And then in the middle are all the startups, right? Looking at smaller niches, right? The niches, like I said, could be drug discovery, right? Could be like I said, hospital data management, patient monitoring, right? Patient monitoring, patient engagement, right? Virtual assistants for patient engagement, wearables, like I said, right, where you're able to capture data on a real-time basis, patient data and risk analytics, right? Looking at data and kind of stratifying patients on the risk levels, imaging and diagnostics, right? So there are multiple areas where you can build, and there are enough folks trying to come at this from multiple angles, right? So it's a fairly exciting space, right? Healthcare, but clearly because the promise of of the value that you can deliver if you are able to build a meaningful solution, right? That can assist in the clinical care process, right? So these are some resources. I can always share them along with through the team here, but that's kind of what I had, right? I hope it is useful, but the thought was kind of just give a sense of what are the opportunities, right, in the space, and then kind of more leave it at these are the opportunities, and then obviously you have different types of capabilities within your teams, within your research teams, in the academic teams, or maybe a likely startup, but there are fairly good opportunities, and as long as you're able to take a focused effort, I think you will be able to make a difference, right? And again, if you're able to tie up with a good clinical mentor or a clinical advisor, yeah. So thanks for that, right? With that I'll stop my share. I'll be happy to take questions. I see one question in the chat, which is yeah. So the question is diagnosis possible in the preliminary stage without any symptoms based on the test reports alone? It is possible, right? So even today we do screening, right? We do screening for oral cancer, we do screening for cervical cancer, we do screening for breast cancer. So this is screening, not diagnostic, right? Where you're just you run a screening camp, the patient walks in, right? And then here typically the patient doesn't report a symptom, right? Especially in the earliest of stages, right? You don't report a symptom, right? I mean, even in prostate, you could go for a proactive PSA, right? And some of these are depending on the, kind of healthcare ecosystem you are, there are guidelines as well. Beyond a certain age, right, you would be asked to go get a screening test, right, for different of these, right. So there is no symptom. The patient would typically be surprised when something suspicious turns up on that first screening test. Typically, it is confirmed, using some by a second level. It could be a biopsy. If a biopsy is at all possible, right? Or you could also do a radioisotope based test, right? Which kind of confirms activity, right, in that suspected area. So it is possible. Yeah.
Any more questions from the audience attendees?
Dinesh sir?
Yes, ma'am. Hello, can you hear me?
Yes, sir.
Yeah.
Hello?
Yes.
Okay, thank you, sir, for
Sure.
such informative talk. We have understood the way an engineer with the knowledge of these current technologies can help in solving the problems of medical field. The fact which you have stated regarding the percentage of people getting wrong treatment is very insightful, and it had motivated us to think of this field. We also got to know.
Not necessarily wrong treatment. They get the best treatment, but given the knowledge of the science available today, that's the best outcome. Right? So only that many patients respond to that line of treatment. Yeah.
Okay. We have also got to know how challenging is this field to help doctors predict the type of treatment after diagnosis. How many iterations they have to do and all. This is very surprising to understand, and complexity is really big, and it has even inspired us, sir. And we want to present some virtual memento to you, sir.
Thank you. Thank you so much. It's nice. I hope it was useful. We'll be happy to take any questions, even post the event. It can be routed through the team. Padma ma'am, you could always route these questions if there are any. Thanks for the opportunity.
Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you very much for your wonderful session.
Absolutely.
Amma, now, Pratisha,
Ma'am, now
4:30.
poster presentation.
After break, they can go for poster presentation 4:30. So through Google link, not WebEx.
Okay, ma'am.
Please inform to all of us, please.
Okay, ma'am. Hello, everyone. Now, if all the sessions of today are completed, now we have poster presentation session at 4:30 p.m., which happens through platform of Google Meet, and we will be sharing the link. After a break of half an hour, you can join that meet link and present your posters.